Is that okay with you, Alan?
Absolutely, that's fine with me.
Okay.
Great, good, thank you.
Okay, thanks, JR.
Um,
It's recording now.
yeah, it is recording now, right?
Mhm.
Yeah. Okay. Good. I sometimes I will forget to do that, but Bob, thanks for reminding me because I appreciate that. And that's why I'm going to turn this down because I don't want to hear it. And I want to thank everybody, like I said, for coming, um, and I'm glad the gas mileage was really good for you. So thanks again, and Alan, I'm going to turn it over to you.
Alrighty, good evening everybody, and thanks for the invitation, Jim. And hopefully you guys will enjoy this. Just by way of introduction, my name is Alan Wolke. I'm W2AEW, and down here in New Jersey. So pardon the accent. So, anyway, Jim asked me to come on and give a talk here, and I've given this presentation that we're going to go through today probably 5 or 6 times already to various amateur radio clubs throughout the country as well as in the UK, and then most recently delivered it at the during the GQRP Club convention a few weeks ago. So I'm an extra class ham, been a ham since about 1979, so a little over 40 years. I also work as my day job as a field application engineer for Tektronix, so I get to play with fun toys all the time. Um, so anyway, and I also serve as the Northern New Jersey ARRL technical coordinator. So anyway, with that, let me all bring up and share my presentation here, and we'll get rolling. I'm fine with answering questions as we go through this. Just ask that if you want to ask a question, unmute yourself, let me know, and then we can address that question. Then remute yourself again, and we'll continue on. So let me turn this into presentation mode. And just let somebody confirm to me that that you can see that in full screen.
Yep, it's clear.
All right, very good. Okay, so the talk is about basically an introduction to what a vector network analyzer is, and then a tutorial on the nano VNA. Okay, and then a little shameless plug for my YouTube channel down there at the bottom. It's youtube.com/W2AEW. Don't worry, I'll remind you about that at the end too. so here's our agenda today. So first off, why do we want to talk about this? And really the reason why I want to talk about this is that we now have these ridiculously inexpensive vector network analyzers called a nano VNA available in the market that make VNAs accessible to hobbyists like us and not just professionals. So now we want to know what they can do, what they can do for us. So first, we'll talk about what a vector network analyzer is, and then second, what it's good for, and then we'll take a look at the nano VNA. I've got, if you're looking at my webcam, you can see I've got this one sitting here. This is the nano VNA H4. So just as an example. So anyways, let's get started. So what is a VNA? All right, VNA stands for Vector Network Analyzer. I know that probably doesn't help clear it up. So if you Googled VNA and get a definition, you'd probably get something like this. An instrument that measures the magnitude and phase of the reflection and transmission properties of a ports of a device versus frequency. I know that doesn't help either. Okay, so let's break this down a little bit further. Okay, and talk about what all this means and why do we care. So a VNA, I've got a couple pictured here, is an instrument that's typically used to characterize RF devices. And it used to only be used by kind of professional RF engineers, mainly due to cost. The unit up there on the top of the stack there is a unit from Tektronix, the company I work for, and that's a $8,000 to $10,000 instrument. Sitting below that is another that's quote unquote a low cost VNA from a professional standpoint. The one down below that is by a company called Copper Mountain in that same price range. Professional units can cost, like I said, $10,000, $5,000, $10,000, or much more. You may want to venture a guess to the price of that Keysight 4-port PNAX. That's one of the more expensive ones on the market, about $240,000. So as you can see, we typically don't, as hams, don't have access to instruments of this quality and this caliber. So most hams haven't really ever played with a VNA, but now we can. Now, when you start researching about how to use a VNA and what it can do for you, you're going to come across a lot of acronyms and a lot of terminology that you might not be familiar with. So we're going to review some of that too, as well as getting into what the VNA can do for us. So one of the terminologies that you run across is a DUT. What is a DUT? Quite simply, a DUT stands for a device under test. Typically a device that could be an antenna, it could be an amplifier, it could be a switch, could be a filter, whatever it might be. It'll typically have at least one port, sometimes two, sometimes more. Okay. Now, any kind of a device that you're testing is going to affect the signal that gets sent to it and that goes through it. Okay. If it's an antenna, it's going to affect what that signal looks like when it hits it. And if it's a filter or amplifier, diplexer, whatever it might be, it's going to affect the signal going through it. The input impedance of that device under test is going to affect the signal that's being applied from the source, okay, whether some of it gets reflected or not, for example. And as they're all learned from basic electronics, if you want to get maximum power transfer from any kind of a source, you want the load impedance to match the source impedance, or load resistance to match the source resistance. And in a more general sense, especially from an RF, we actually want the source and load to have a complex conjugate relationship. We're not going to talk too much if we can try to avoid talking about complex numbers and things like that, but I just wanted to kind of throw that out there because it's something that you run across and see. Okay. So when we talk about signals in the RF domain, we like to think of them as waves. Okay. And if you think about a signal that has a wave, you can think of it as having a magnitude and a phase. And some people get confused oftentimes by the term phase. And in reality, it's really just you can think of it as just a delay, right? If you drew out a sine wave or a cosine wave, they only differ by 90 degrees in phase, or basically just sliding the signal with respect to one or the other, by 90 degrees, okay, which is just a time delay. The little moving graphic that I have there is kind of simulating some kind of an RF source, putting out the waveform that's in blue, going out to a load, and then that load is gradually getting further and further away. So the reflection coming off of that reflects back as that red wave that looks like it's moving across, just to kind of show you that the phase will, of a transmitted signal and a reflected signal will vary depending on the distance that it travels. So again, because the distance is time delay. So think of phase as just another measure of time delay in a sense. So we think about signals as waves, and we've got this source applying a signal to a DUT. What kind of things can we characterize? So we've got a source, a source producing a signal going into the input port of some DUT, an antenna, a filter, whatever. Some of that signal, ideally all of it, is going to go through that DUT, and we call that the transmission properties of the DUT. And then if you don't have a perfect match between the transmission line and the input impedance of the DUT, you may have some of that signal reflected back towards the source, and that will be called the reflection properties of the DUT. Okay. So the DUT reflection and transmission will alter the magnitude and phase of the signal being produced by the source. And this is essentially, from a high level, what a VNA measures in a raw sense, and then we characterize it in a number of different ways. But at the end of the day, we're looking essentially at magnitude and phase of transmission and reflection properties of an RF signal and a device. And that's what a VNA does. So let's clarify that a little bit more. So this is what a basic VNA looks like. I mean, a very basic VNA, like in the sense of the nano VNA that we're going to be talking about, looks a bit like this. We've got, let me pull up a little laser pointer here, so it's a little easier to see. So we've got an RF source here that's producing an RF signal. That signal is then going to be sent out of what we will call port 1 out of the VNA down to our device under test. And then anything that goes through our device under test, if it happens to be a 2-port device, is measured through port 2. So inside the VNA, we'll have a set of couplers or bridges that will sample the signal that's going in both directions. Now, ideally, we're going to sample the signal that's being transmitted out to the device, essentially the source. So we're going to sample that in a receiver that we'll call R. And then any signal that is reflected off of that input port because of a mismatch will come back down this line and then be sampled by this coupler here. Okay. So we have these various receivers that measure the forward signal, the reflected signal, and the transmitted signal. And they measure both the magnitude and phase with respect to the source that's being generated. So that's really what happens inside of a VNA, is in terms of the signal processing, in terms of where the signal flow is. There's a compute and display engine that will take all the results from the reference receiver and the A and B receiver, and then compute the various results in various formats. So what we'll measure, for example, like on the transmission properties, we can measure such as gain or loss of a device. Again, helpful if you're looking at a filter, a duplexer, etc., things like that. One way to characterize that is something called the transmission coefficient, or S21. We'll define what S parameters are here in a moment. But also we can characterize the insertion phase, or something called the group delay, basically the delay through that device. And these are all transmission properties, of a DUT. So in addition to the transmission properties, we can measure reflection properties of the DUT. And these are probably the ones that we're most familiar with, right? Something like SWR, standing wave ratio. Another property is the reflection coefficient, or S11 in this case, or return loss, which is really just a reflection coefficient with the sign changed. Okay, or even you can even measure input impedance. You can compute that from here. And if you look at these carefully, the reflection measurements are based on this ratio, the measurement made in the A receiver as compared to the R receiver, so A over R, where the transmission properties are the measurements made in the B receiver with respect to R, so that's B over R. So that's where all the math and computations happen, is just by taking A over R for the reflection properties and B over R for the transmission properties. Now, most professional VNAs, not these little nano VNAs that we got here to play with, most professional VNAs will have a source and couplers on the other port as well, because then they can measure reflection properties at the output of a DUT, as well as measuring reverse transmission or isolation measurements. Okay, so that would give rise to S22 and S12 measurements, as opposed to the S11 and S21 measurements. Okay, so what's this all good for? What can we measure with a VNA? So on the reflection port, obviously the SWR of an antenna or antenna system. We can measure the complex impedance looking into that DUT. You might want to know the complex impedance looking into an antenna or an antenna system to design a matching network, for example. You might want to know the impedance into an amplifier or something like that to better couple power into it, that type of thing. We can also measure basic components, resistors, inductors, and capacitors, at least over a limited range. You're not going to get the same range as you would with a proper, LC meter or even a DMM for resistors. But over a limited range, you can get a pretty decent measurement of especially inductor and capacitive properties, and to look at how they behave over frequency. You can also measure the length of a feed line. Now that's a distance measurement, not a frequency measurement, but with some math inside the VNA, we can actually compute that to get like feed line length or a distance to fault, on a coax. So if you've got a problem going up a tower, you might be able to measure, okay, I know that my problem is 50 feet down the coax, so you know how far you got to climb to find where the issue might be. Okay. On the transmission side of things, we can measure things like the filter shape or loss through a filter, the skirts of the filter, how wide it is, that type of a thing. We can look at loss in a feed line. Okay. We can look at the delay in a device under test. Even look at amplifier gain and frequency response. Do the same thing for a duplexer, things like that. So at the end of the day, we're talking about measuring things that we use all the time: antennas, duplexers, filters, inductors, capacitors, amps, splitters, balance, etc. All of these things can essentially be characterized with a VNA. Okay, any questions so far? All right, good. So no snoring, no questions, so we're good. Okay. So the next thing I want to define a little bit is just to clear up what are S parameters. Okay, again, S stands for scattering, so they're called scattering parameters. And again, I realize that definition doesn't help you. So let's talk about what this is. So it's really a ratio. It's basically that same ratio that we talked about. And it's just represented by this little three number, kind of symbol where it's essentially the response at the port indicated by the position where X is here in response to a signal applied at this port. So S21 is the response measured at port 2 in response to a signal being applied to port 1. So that's what S21 is. So it's essentially that B over R, thing that we talked about. S11 is the response measured at port 1 in response to the signal being applied by port 1, right? If we had a perfect impedance match, right, we'd have nothing reflected back and that ratio would be close to 0, right? So another way to look at it is S11 is the measurement of the reflected signal A divided by the signal being applied. We'll call that R for reference. But unfortunately, that's the terminology that we use. I know we can confuse R with reflected, but in this case, R is our reference, what we're applying. So it's that ratio of A over R is S11. Okay, and that you can call that the reflection at the DUT port. Similarly, S21 is the measure of the signal coming through that DUT in response to the signal being applied at the input, or by R in this case. All right. So again, it's that B over R. So quite simply, that's what the S parameters mean. So sometimes you might see maybe S22. What does S22 mean? Well, that means that I've got a source on port 2, and I'm measuring the reflection off of, in this case, the output port coming back to port 2. So that's S22. S12 would be the isolation or reverse isolation of a device. So if I send a signal going the opposite direction that I'm shown here, that would be S12, right? The response measured on port 1 with respect to port 2. So that's really all the S parameters really mean. Okay, so don't be scared by when someone says what's an S parameter. That's what it is. And then the fancy name for it is reflection coefficient and transmission coefficient. Okay, everybody good? Okay. So one other confusing thing that people run across is say, oh, VNA is complicated. You have to do this calibration on it all the time. What does that mean? And what we're talking about is actually something called a user calibration. And there's a reason why you've got to do this. So why do we have to do a user calibration on a VNA? Well, it's because one reason is because the VNA has a very large measurement dynamic range. Even these little cheap nano VNAs that we can pick up, we've got a dynamic range in the neighborhood of 50, 50, 60, even 70 dB. So 70 dB, that's an order of, that's a factor of 10 million to 1, right? So in order to do that, any tiny little mismatches or things that we do to how we hook something up can affect the measurement. So we want to calibrate much of that out. So that's one of the reasons why we do a user cal. Another one is that we're measuring a phase. Remember what I said about phase? Phase is really just a measurement of delay. So if I've got to take a piece of coax to hook up from my nano VNA to my device, there's going to be some delay associated with that. So if we just measured it, we're going to measure that delay in addition to whatever alteration in phase that my device is going to do. So by doing a calibration, we establish something called a measurement plane. So what we're effectively doing is calibrating out all of the other connections that we're making to our device. So we can make sure that when we measure phase, it's with respect to the right at the port of our DUT for those instances where we care about measuring phase. Okay, but that's really one of the reasons. So now obviously a calibration done at the factory can't account for these things, right? Because it doesn't know what you're hooking up. It doesn't know what the cables are. It doesn't know how you're using it. So you can't just have a factory cal do everything like an oscilloscope, for example, because here we're measuring things that are kind of beyond what the factory can account for. So that's the reason you do a user calibration. Okay. And when we do a calibration is whenever there's a configuration change, meaning I've got a different set of cables, or I've changed the adapters, or I've changed the fixture, or most commonly, when you define a new measurement frequency range that you want to measure. That's when you do a quick user cal. And it's a simple thing to do. The menus walk you right through it, but it is something that, if you pick up your MFJ 259, well, I don't have to calibrate this. Why do I have to calibrate the nano VNA? Well, these are the reasons why. Okay. So a little bit deeper. So the user calibration corrects for what we can call systematic error sources. Systematic error sources are things like what we call tracking errors. And this is measuring and calibrating out the source and receiver frequency response. So we want to flatten those out, take them out so they're not part of our measurement. That's part of what the calibration does. Also, will take care of any source and load mismatches at the device ports of the VNA. So any mismatch here and here can affect our signals. And we want to remove that contribution so we're only measuring from our device. Also, leakage or directivity and crosstalk. We have these couplers that are measuring and sampling the signal that are going in both directions. Ideally, that's how they work, right? Our receiver would only see the signal that's going in this direction and nothing coming back the other way. It won't respond to it. But the reality is there's a little bit of imperfection in all of these devices, that they respond a little bit to the signal going in the opposite direction. We call that directivity. And then you may have some crosstalk between the ports, meaning the signal might crosstalk from one port to the other without going through the DUT. So you want to take care of those leakage and directivity and crosstalk issues. So that's another thing that the um, calibration will do for you. And then of course it takes care of any of the user cables and fixtures. So we establish the measurement plane right at the input and output ports of our DUT. So this is what a user calibration does for you. Okay. So when you look at measurements on a VNA, there's a lot of different formats that those measurements can take. Now, most cases, when we're making measurements on a VNA, we're making measurements with respect to frequency. So we're going to scan over a certain frequency range and make measurements associated with that. Excuse me. So the reflection coefficient, or S11, again, that's that A over R measurement. Most often we're just going to look at, if we're not looking at phase, we're just going to look at the magnitude of it. We actually use a log magnitude display, like most spectrum analyzers do. Okay, and the reason for that is it gives us a lot of dynamic range on the screen. Okay, it's easy to see something that's 50 or 60 dB down, on a log magnitude display. That would be very, very tough or impossible to see that same thing if it was a linear scale. SWR, on the other hand, is typically a linear scale and just displaying the ratio that we're typically used to. Complex impedance is most often represented on a Smith chart. I'm not going to talk a whole lot about the Smith chart tonight. That's a whole nother topic that I've got a whole nother talk on. If anybody ever wants to hear that, we can talk about Smith charts ad nauseum. Okay, but that's typically how a complex impedance is represented versus frequency. It's the most common way to see it. It does a whole lot of other things too, but that's just what you'll see on a VNA. The transmission coefficient, much like the reflection coefficient, again, we display that in a log magnitude format. And then things like insertion delay, insertion phase, or group delay, they're typically a linear measurement, either in degrees or seconds, depending on what display you're looking at. And then there's a mathematical transform that the VNA can do to make those measurements versus time. That are things like looking at the distance to fault or a length of coax or something. That's all. And typically what it'll do is it'll use the reflection coefficient to make the measurement. But if you change it to a linear instead of a log magnitude, you get a much sharper peak in the response. So it's easier to see what's going on. And I'll show you an image of this later on to illustrate what I'm talking about. All right, so before I jump into the Nano VNA, quick pause here to see if there's any questions. I didn't have the chat window open here to see if there was any questions showing up in the chat. I don't know if somebody could tell me that or not, but otherwise I think we can continue on.
Nothing found.
All right, good. Okay.
It seems like those little A receivers and B receivers are seemingly very simple schematically, but there must be a nice way to distinguish a transmitted signal or the source, whatever it is, reference signal versus a reflected signal. Anyway, I don't know if there's an easy way to explain how that works. But it is a question somewhere along. It would be somewhere along the line of people.
If we scoot back to the picture here, just to kind of start with, I mean, it all kind of comes down to the fact that the A, B, and R receivers are typically separate receivers. Like this one is only going to be looking at port 2. This one's only looking at effectively what's being reflected back through this coupler coming in this direction. It's not going to see the signals going forward. So the receivers don't have to do any separation. It really comes down to the couplers doing that for you. Okay, and again, it's either a directional coupler or sometimes a bridge. Okay, and in the case of the Nano VNA, it's a bridge that's used. Okay, but we'll talk about how that works a little bit. Okay, so all right, so the Nano VNA. One thing you'll find is that there are several developers and variants. The whole thing about this Nano VNA is it's not like a device from MFJ or Rig Expert or somebody like that. There's not one manufacturer. It started off as a kind of a public domain project that somebody posted on GitHub. And a couple of developers picked up on it and said, hey, this would be great to kind of mass produce. And now we've got many people mass producing effectively to the same design or some minor design variants. So as a result, there's a lot of different variations and versions that are out there. The original, that's kind of very popular, is popularized by a developer. I think his name was Hugin, or that was his handle or something like that. Came out initially with just a little 2.8-inch display, about the size of a little bit smaller than a credit card. The unit I have is the H4 that's got a 4-inch display on it. Okay, basically the same RF hardware, but with a larger physical display to make it easier to use. And the original came out, didn't even have a case. It just was a stack of boards kind of bolted together. And then later on, there was a case available, and then the the H4 has also got this nice plastic molded case. There's also a very popular one called the Nano VNA-F, and it's also got a 4-inch display. But the nice thing about the F is that it has a aluminum case instead of a plastic case, so it's a little bit more rugged. It has a couple of additional nice features in it. It's a little more expensive than the H4, for example. And now kind of the latest one that is out there now, again, a number of variants, is called the SAA2. It's sometimes called the V2. It goes up higher in frequency. These others go up to either 900 meg or 1.5 gig. The version 2 goes up to 3 gigahertz. Again, initially introduced with just a stack of boards, and also now starting to become available in a case with a couple of different connector options and stuff like that. So as of late summer 2020, okay, again, because this is a moving picture and it's an open source thing, so it's always changing. I still kind of like the H4. That's the one I've got here. It's available from, it's very easily available in the U.S. From R&L Electronics. They sell it to you. It's about $60. There's a ton of them out there, so you get good support. There's a number of people that are actually making firmware for it, and some of them with the firmware update is pretty easy to do. So I've got a third-party firmware running on mine that's got some nice features in it. And then also just in the last, I would call it even the last 6-8 weeks, we've seen this one called the SAA2 that I mentioned is now being offered by at least one developer. I've got this one here as what's called the SAA2N, which is the SAA2, but in a metal case with N connectors on it. And it's probably 4 times the weight of that Nano VNA H4. And it goes up to 3 gigahertz with a 4-inch display. But all of the other ones are again, a 2.8-inch display. But it's a picture that's always changing. But for the price of these things, like I said, you spend more to go out to dinner one night than you will on a VNA. So it's not bad to pick them up as they come out if you're so inclined to play with these things. So a couple more details on the Nano VNA. All of them thus far are what are called 2-port, 1-path. And that's kind of the block diagram I showed you, where they've got 2 ports on them, but only one RF path, right? There's only one source. So you can only measure transmission in one direction. So that's why it's called a 2-port, 1-path. Okay. The H4 that I showed you goes from about 50 kilohertz up to 1.5 gigahertz in terms of frequency range. They do offer standalone operation. They've got a built-in battery, so you can use them for a few hours before you have to recharge the battery again. Just about all of them do support the use of a PC-based and in some cases an Android-based application that offer some additional features. You just connect up through a USB port to the device. Good place to start for any of these things, just nanovna.com. There's just a ton of information there, wiki pages, links to the user groups and mail lists and things like that. So in fact, this is the user group for the NanoVNA, and there's just a bunch of links that you'll find up on those pages to find things. And for the SAA2, the kind of the somewhat unfortunate thing is that the original guys that developed the SAA2 kind of, again, open sourced it, so that's good, but at least one of the clone manufacturers picked it up and started manipulating the market a bit in terms of kind of falsifying the reviews that they get, and then even selling these things at, like, dumping them on the market almost at cost. So it's kind of hurting the original developers. So there's a whole mess going on there, but you can still pick these up and play with them. Okay. And as a result, there's two different user groups for the SEA2, the official group and then another one. So, but it's just unfortunately the nature of kind of these open source things. But on the not the version 2, but the like the H version that I'm using is actually a pretty stable and reliable place to go. So underneath the hood of the NanoVNA is this, and this is kind of the basic schematic or high-level schematic of the H and the H4, and we've got essentially they call it a channel 0 and channel 1, and this really relates to port 1 and port 2 on a traditional VNA. So there's an RF source down here, okay, just a little SPI bus controlled synthesizer. Called a SI5351. Anybody who does any kind of QRP work is probably familiar with building with this little synthesizer. So it provides a signal out to the bridge, and then the bridge is what sends the signal out to the device under test. Any mismatch to the bridge is then a signal that goes out to this receiver here. Again, the bridge is used instead of a coupler. These very familiar, old school SA612 or SA602 type of Gilbert cell mixers are used to take the input signal, the signal coming from the bridge, as well as the input signal, and basically mix them down effectively to audio. So the receivers are all inside this guy right here, which is a stereo audio codec that's got a couple of really nice high quality digitizers for audio. But because we've mixed these signals down to audio, we actually do all the sampling here. So the three receivers really consist of these three mixers that take the RF, mix it down to audio level signals in the tens of kilohertz or less, and that gets essentially digitized in this very inexpensive audio codec. And then all of that is controlled by a microcontroller, and then that also sends the data out to the LCD display. So that's kind of the high level block diagram. This is the actual schematic of the H4. I'm not going to go through it in detail, but you can kind of see where the various bits and pieces are here. Oops, let me go back. So here's our, this is the RF source. That's a SI5351. You can see right here, looks like the classic bridge, right? And if you put a perfect 50 ohm resistor here, you'd see the classic Wheatstone bridge, and we're measuring the voltage across the bridge, right? So if this had a perfect 50 ohm load, the voltage on either side of this resistor right here would be the same, and we'd measure nothing through this mixer into the receiver. So that's how we separate transmit and receive, forward and reflected, if you will, is just by the balance in that bridge. And then there's just a pad that's used here to receive on the other port. And then we've got the other mixer to measure the reference. So it's as simple as that. So all those mixers send their outputs to this audio codec. That's all just controlled by the microcontroller. Okay, so it's a pretty simple design. Okay, the SAA2 that I showed you has actually got a different schematic design on it than this one here, but I'm not going to go through the details of that. Okay. So let's talk about the user interface on the NanoVNA. So right on the top of the unit is this you see a little half wheel sticking out of the top, and that's a jog wheel. You can rock it back and forth to move things and move through menus and move markers and stuff back and forth, and you can push it to select things. Okay. It also is a touch screen, so you can touch it to select things. You can tap and slide to move things. Okay, so it's pretty intuitive. If anybody who's used a smartphone can figure that part of it out. There's a fairly simple menu structure. Even though there are variants from various developers and things like that, most of the menu structure is probably 95% the same between all these different developers. Okay, there's a display menu that allows you to go through traces and channels and formats. There's a marker menu to put markers up, a stimulus measure to control what frequency range you're measuring over, etc. Okay. There's also slots to save calibration setups so that if you make a measurement over a certain frequency range all the time, like maybe you're playing with designing a receiver and you've got a 9 megahertz IF and you're designing a filter for that and you're working on that over time, you can do one calibration for over the frequency range to characterize that 9 megahertz filter, save that. So each time you power the unit up, you can recall that, save that calibration, not have to repeat the calibration again. So there's slots available, memory slots available to save those calibration results to start over and repeat measurements. And of course, there's a USB port for both charging the device and to connect up to a PC with some external software. Okay. So the calibration, one thing to remember is that most of the nano VNAs only sweep 101 points over whatever frequency range you decide. Okay. So when you do a calibration, that means that your spacing for your calibrated points, if you will, is going to be equal to the frequency span divided by 101. Okay. Um, and the VNAs will interpolate between those points if you adjust over a narrower, you set the span to a narrower range than what you calibrated. But it's always best, because you've got this relatively coarse spacing, is to make the calibration over the specific frequency range you're measuring. Now, most interpolate between the points, but it's always a good idea, again, to calibrate over that frequency range. I've got a little asterisk here because some firmware, like the one that I run on my Nano H4, have increased the number of points that this H4 can do. It'll actually do 201 or even 401 points. So that'll decrease the spacing between your calibrated points, which is good. But again, not all the firmware has that. So that's why I put the asterisk there. Okay. So the display indications for calibration, I know I'm spending a lot of time on this, but this is the thing that most people get confused about. That's why I'm spending more time on calibration. The display indications for the calibration occur all the way on the left-hand side of the screen, and these letters all mean something. The first entry will show either capital C, meaning that I'm calibrated for the current frequency range. So whatever you did the calibration for, the measurement range matches that, and you're calibrated. If the letter is a small c, not capital C, it means that you've got a calibration over the frequency range, but it's not exactly the same frequency range. So it's doing some interpolation. That's what the small c means. The number following that tells you which slot that calibration setup is loaded into, so you can recall it later on. Okay. The next three letters, D, R, and S, stand for directivity, reflection, and source. And we talked about the different things that a calibration will correct for. And this just indicates that the directivity, reflection, and source corrections have been applied. Okay. And then the T and the X are the transmission error and crosstalk error are being applied. Okay. Now, these three are needed for all measurements, whether you're making reflection measurements or transmission measurements, you need to have all of these done. If you're only making reflection measurements, like looking at an antenna or something like that, you don't need the other two. So you don't have to do the calibrations associated with the other port with channel 1. They're only required when you're making transmission measurements. So it's perfectly valid if you're only going to use it as an antenna analyzer, just do the first 3 steps of the calibration process and ignore the other 2. Okay. So how do you do the calibration? And again, this will just run you through to kind of show you the menu steps. So this is the root menu, or the bottom menu, or the main menu for the VNA. So you hit cal, that brings up the calibrate menu, and then you hit reset. Once reset basically resets the existing calibration standards or calibration corrections that are loaded. And then once you hit reset, then you hit calibrate, and then calibrate will bring up this menu over here. And what this is prompting you for is to attach a open to channel 0. And then once you touch that and connect the open and touch that, then it'll prompt you to add the short. Then it'll prompt you to add the load. Okay, and if you're only doing, again, the single port measurements, you could just hit done at that point. Okay, again, because those are required for all the measurements. If you're going to be making transmission measurements of any sort to look at loss in a coax or whatever it might be, then you want to do the isolation and through measurements. And that's the isolation measurement is either leaving the ports open, or you could attach a load to channel 1 to kind of isolate it even further. And then the through is connecting the ports together. So once you've done the first 3 or all 5, then you hit done. Okay, and then it'll prompt you for a memory slot. What memory slot do you want to load things into? Now, most of the VNA firmwares will automatically recall whatever's in slot 0 when you power it up. So if it's something you do all the time, or you do most commonly, store it in slot 0. So you power it up and it's ready to go. Okay. And ideally, what you're going to want to do is connect all of the CAL standards, the open, load, and short, to the same place where you would normally connect your device under test. And this establishes that measurement plane that we talked about. And we're going to talk about more next. So again, what I'm referring to is I'm connecting up to my device under test here. If I want to do a calibration, I want to calibrate to this point right here. So that means taking the connector off of here and connecting that to where my standard would go. And same thing here, I would take this and connect, that's where my standard would go. Okay. And this removes the phase of the interconnect to the DUT to establish that measurement plane right at the device. Now, sometimes you have a different connector style, right? My calibration standards are one connector type, but then if I'm connecting up to an antenna or something like that, that's a different connector type. So what do? So you can use an adapter. Maybe you got to use coax, or you got to use a fixture, or you got to do something else to connect up to your standard compared to your device. So what do you do about that if you want to remove that out of there? One of the things you can do is something called port extensions. If whatever you add to connect up to your device is just an extension of the 50 ohm environment that the coax is bringing, the port extension is just allowing you to add that amount of delay to the calibration. Okay, so the nano VNA calls this electrical delay, and it's really and you can adjust this by actually using the Smith chart. Because the Smith chart, if you looked at the Smith chart, all the way over in the 3 o'clock position represents a perfect open. All the way over in the 9 o'clock position, not shown over here, would be a perfect short. So if you had to connect this adapter, or I've got a trace going onto a board or something like that, and you want to calibrate to that point, you want to do a port extension to that point, you could leave it open or apply a short at that point. And because the extra delay, you might not be perfectly at the 3 o'clock or 9 o'clock position. So you can literally add there's a parameter for electrical delay, and you dial in a number until you rotate where you've measured to that ideal open or short position. And that effectively dials out the delay of whatever extension, connector, adapter, coax you've added. Okay. Again, it's really only important when you must have an accurate phase measurement at your device under test, which isn't always the case, and sometimes you don't worry about it. Okay, but that's really what it does. Okay. So enough about calibration. Okay. So let's talk about some of the other user interface things here, and I'll show you a couple of examples. Okay. Actually, before I move on, are there any questions on calibration?
I have a question, if you don't mind.
Sure.
Are all these instructions in some sort of book that comes with the VNA device?
Unfortunately, no.
Good.
So
Oh, wonderful.
yeah. So what you get, actually, what's funny, let me see if I have one here. Hold on a minute. I don't know if you can look at my webcam, maybe you can see my little image there. Here's what you get.
Oh.
There's the manual. Okay, it's
All of that.
it's basically a menu map, and that's it. Okay, so but if you go to the website that I mentioned there, that nanovna.com, there is a link there to a manual. In some cases, it's translated from Chinese or Japanese or something like that. But they're also probably your best resource is there's a number of YouTube channels, including my own, that have got step-by-step procedures for doing the common tasks that we'll do. I've got a video of how to sweep an antenna. I've got a filter of how to measure a filter. I've got a couple of videos of how to do these things, and that's probably the best way to do it. Okay, but I'll give you a couple of, walking through the menu structure here and then show a couple of examples of what that would do. Okay,
Okay, thank you.
sure. So on the Nano VNA, we have these things called channels and traces, right? Because the VNA has got 2 ports on it. The Nano VNA nomenclature calls those ports channels. They call it channel 0 and channel 1. Okay. In fact, if you look, I don't know if you can kind of see this in my camera, you can see it says CH0, CH1. And if you look at the other values below that, one of them says S11, and that's kind of the reflection port that refers to channel 0, and then S21 refers to channel 1. So it's really the reflection and transmission ports are channel 0, channel 1. Okay. So again, channel 0 is the reflection port, and that's where you measure S11, SWR, input impedance, distance to fault. Those are all measurements that are made using channel 0 on the device. Channel 1 is the port that is just the receiver to measure the transmission properties of the device, such as loss and gain characteristics, group delay, that type of thing. Okay. So on those ports, we can assign various traces to measure different things. Like, for example, I can measure S11 on one trace, VSWR on another trace, and input impedance on a third trace, all measuring on channel 0. Okay. So the traces, you can have up to 4 traces, and those traces can be assigned to any of the channels. So if I bring up display and go to trace, I've got trace 1, 2, 3, and 4. And then you pick one of those traces, and then you can tell it which channel you want that trace to be on. Okay. So whether you want that trace to measure a reflection property or a transmission property. Okay. And that's what the menu structure looks like to go do it. You go to display, trace, select your trace, and this is where you would turn traces on and off, and then select whichever one is the active trace. And then back on this menu again, select channel, boom. Okay. So then common trace formats, again, the same menu, display, then trace, then the next item down, and so is the format. So for a selected trace, what do you want the format of that trace to be? Okay, and these are the most common ones. Okay, for channel 0, you're typically using log magnitude of S11 to look at the reflection coefficient, or you might be looking at it as SWR, which will give you a linear, or you might look at Smith chart to look at complex impedance. Those are the most common ones. For the channel 1 or transmission channel, and any traces associated with that, oftentimes, again, it's log magnitude of the loss or gain through the device under test, or you're measuring phase through the device, or the delay or group delay through a device. So again, those are the most common formats. There are other formats that you can use depending on what it is you're trying to extract from the thing you're measuring. But these are the most common ones that you'll use probably 90% of the time. Okay. And then of course there's the more. Okay. So when you go to measure anything, you typically have to tell it over what frequency range do I want to make this measurement. So that's what happens under the stimulus menu. Okay. And the stimulus menu allows you to define the frequency range one of 2 ways. You can set the start and stop frequency over what, I want to start at 14 megahertz and stop at 14.3. Okay. Or you can set the center frequency and span. Okay, if you're measuring an antenna, sometimes it's easy to set the start and stop. You want to set it at the band edges, for example. But if you're measuring a filter, you might say, I know the center frequency of my filter is supposed to be 455 kilohertz, and I want to measure, 100 kilohertz around that. Okay, so that's center and span. So you pick whichever one of those 2 is the most convenient for the situation that you're measuring. And selecting any one of those buttons will bring up a numeric keypad on the display for you to enter the numbers in. There is the ability to set up a CW frequency. So if you only want to measure something at one frequency, you can go do that instead of doing a sweep. So that's what the CW frequency is for. Okay. And then there's markers. You have up to 4 markers available on most of on any of the VNA firmware that I've seen. You have up to 4 markers available. And so if you look at the display, this is kind of a typical display here. I could see channel, like the yellow trace is channel 0 showing log magnitude. So log magnitude, since it's channel 0, it's log magnitude of S11. And the 10 dB means that's 10 dB per division. Okay, so the 10 dB slash means it's 10 dB per division. And the value following that is the value of where the active marker is. Okay, the active marker is shown right down here. In this case, its active marker is 2. So if I look at marker number 2, it's sitting at 360 megahertz, and its value on channel 0 is minus 8.19 dB. Okay, so the selected marker again is shown there. The delta, the D1, when you bring up a second marker, it's going to give you the delta from that marker you just brought up, the active marker, in this case 2, with respect to the previous marker that you selected, which in this case was 1. So now I've got an active marker of 2 and the delta of 2 to 1. So if I want to measure some parameter between two markers, like the ratio of gain from this frequency to that frequency, you'd bring up those two markers and the delta would give you that. Okay. Let's see. So all the markers track each other on all the traces. So again, you have 4 markers, you bring them up and you move a marker and frequency back and forth. It moves on all the other traces at the same time. So like in this case, channel 0 measuring the Smith chart, which is measuring the input impedance. That's this little curly Q line looking at the circular scale. Okay, its value right here, because it's marker number 2, is showing a 22 ohm and 50 picofarad impedance at that location. Okay. There are search features for the markers to allow you to search for the min and max, or just go left and right to the next min and the next max. And there's operations to allow you to say, hey, I want to take where this marker is in frequency. I want to make that the new center frequency for my measurement. So that's what the operations allow you to do, is to set the start, stop, center, or span based on marker position. Okay. These are typical features that you have in a spectrum analyzer, for example. And then you can also set the Smith chart values, whether you want it to show impedance and reactance, or resistance and capacitance or inductance, or magnitude and phase of impedance or something like that. That's the Smith value. Okay. So here's your basic setup process to actually use a nano VNA to do something. You can start off by configuring what traces and channels and format you want, right? I want to measure, I'm going to measure an antenna, so I want to look at reflection coefficient and SWR. They're both on channel 0. I set up those two traces, set up the formats, done. Okay. And set up the stimulus frequency range. Over what frequency range do I want to make the measurement? Okay, start frequency and stop frequency, or center frequency and span. These two items can be done interchangeably. You don't have to do one before the other. Okay. The third step, run the calibration. Okay, now you set that new frequency range. I want to calibrate and save it. Of course, if you've done that previously over that frequency range, just recall that calibration, and then all of this is already done for you. The calibration, when you save it into a slot, not only remembers the calibration, but it also remembers what traces and channels and formats you've set up and the frequency range you've set up. So it's kind of a handy starting point. If you're messing around with a 20-meter dipole, you do the calibration once from 14 to 14.3, and you save it, and then you go up in the tree, you do your things, and you come back down, you try it again. You can just fire it up and reload that calibration again. And then you connect up your device and you make your measurements. You can throw on markers, adjust any traces and formats. You can add traces, take things away. As long as you don't change the frequency range, you can just add and subtract traces and things like that, and do that as much as you want. Because all those measurements are literally all just different math on the same set of computed transmission and reflection properties of the device. Okay, so let's take a look at a couple of examples of what this looks like. So here's an example of measuring an antenna and what the display looks like. So you can see down here, this is the frequency range. So in this case, I was looking at a 40-meter dipole, okay, going through my antenna tuner. So start at 7 meg, stop at 7.3, okay. This trace right here shows up blue on the display, shows up kind of whitish on the video here. That's channel 0. So that's the SWR. It's 1 per. So the ratio. So this would be a 1-to-1, 2-to-1, 3-to-1, 4-to-1. Okay. So I can see the 2-to-1 SWR bandwidth of my antenna is about half of that frequency range, right? Okay. And then if we look at my marker, unfortunately, I left it way over here at 7 megahertz. So my SWR all the way at the low end of the band is 4.73 to 1, right? The complex impedance looking into the antenna is this little arc right here. Again, that's using the circular scale here for the Smith chart. Again, another topic, but that's showing me the complex impedance. Okay. The yellow trace Again, channel 0, it's a reflection property as well. That's the log magnitude of the reflection coefficient at 10 dB per division. And again, all the way down here, it's 3.71 dB, which is kind of a lousy reflection coefficient. That corresponds to that 4.73 to 1 SWR. Okay, so that's what this display looks like. Now, if I turned off this green trace, the curly Q axes for the Smith chart would go away. You just have a grid. It'd be a little bit simpler display. I probably should have done that for this particular example, but that's what it looks like. Okay. Let's say I want to measure a filter. In this case, I was looking at a low pass filter that I designed for I built a little Michigan Mighty Mite QRP transmitter using a color burst crystal, okay, which is a 3.56 megahertz crystal. And the Michigan Mighty Mite is a single transistor oscillator effectively, and its output is pretty distorted. So you want to follow it with a low pass filter so you don't transmit on the second and third and fourth and fifth harmonic of that signal. So this is a low pass filter I designed for that. So again, start at 1 meg, stop at 15 meg. Okay, and this is now looking at, if we look at this, I've got, again, the frequency range down here. This is the insertion loss of that filter. So down at low frequencies from 1 meg, you can see that I was basically pretty flat. Then I start rolling off here at about 4 megahertz or so. The SWR looking into that filter, that's this purple trace right here. Okay, looking in is actually well under 2 to 1. So actually it doesn't look too bad, about 1.5 to 1 in worst case here. Okay, and then it rockets up as soon as we start rolling past the filter corner. Okay, the insertion loss there. There's the reflection coefficient. Again, just a different mathematical variant of the reflection properties. Okay, and then the input impedance looking into the filter I've got shown here as well. In this case, I've got the marker sitting at a little over 10 megahertz, so I'm actually looking at the third harmonic. Okay, and I just want to see how far down that third harmonic is compared to essentially my fundamental at 3.56. And we can see that in the case of the insertion loss, that's this guy right here, that marker at 10.5 megahertz, I'm down about 47 dB. So I'm going to be attenuating whatever that third harmonic is by 47 dB. And we can kind of tell from the reflection coefficient and even the SWR that the way that I'm attenuating that is that I'm reflecting it off of the input of the filter. It's never getting through. It's just being reflected back towards the transmitter effectively. Okay, but that's how you measure a filter and what it would look like. In this case, I probably didn't even have to have the complex impedance on there because I didn't really care too much about what it looked like. As long as the SWR is good, I didn't care, but I left it on there. Now, measuring the length of coax. This uses something called a transform function. It's in the menu structure. They are effectively measuring the channel 0, which is the reflection property or reflection coefficient. But ideally, you want to change it to a linear unit because a logarithmic unit's got so much dynamic range, the trace would look kind of like a lobe, if you will, would be more rounded. A linear result gives you a nice sharp peak. So here we can see I put the marker on the peak and it's actually measuring the distance is 76 nanoseconds, or in this case about just a little over 9 meters. So it was like a 21-foot cable a coax cable that I hooked up to the end of this. And so that's what it was measuring. So that's, and again, it uses a time domain transform. So the display here is actually in time, not in frequency. And of course, if you turn the transform off, you could measure, connect up the coax to the other terminal and measure loss, through the coax. You just don't do both of those at the same time. So measuring coax loss is a very similar process to measuring the low pass filter that I showed you earlier. Okay. So with all of this, we kind of talked about a lot of the good, about the nano VNA, very flexible, lots of measurement capability, ridiculously inexpensive. Now, of course, because of all that, there's going to be some bad and ugly associated with that as well. Okay, so what are some of those things? One of those is only 101 trace points. And again, I mentioned that some of the firmware versions give you some, a little bit more than 101 points, but most of them are just 101 trace points. And of course, on a display that small, sometimes more than that doesn't really matter. But this is where some external software can help. So you're running some of the software on a PC. the PC can actually ask for measurements over multiple frequency ranges and stitch them all together and effectively get hundreds of points across a sweep. But that means that you're now tethered or tied to a PC to do these measurements. So depends on your use case whether that's fine with you or not. Okay. So again, the third-party firmware, as I mentioned, like that I'm running here, gives me up to 400 points. Now on the Nano VNA H series, like the H and the H4, like the one that I've got here, you have to remember that the output is a square wave, about 600 millivolts peak to peak. And then the square wave is only adjustable over a certain frequency range. So above a certain frequency range, we actually use the third harmonic and the fifth harmonic off the square wave. Okay, so this might cause problems if you're measuring a broadband device or something like that. Okay, so for example, on the scope trace that I've got down here, this square wave that you see in the time domain view, again, it's about 600 millivolts peak to peak at 200 megahertz. That's the same output that I would get if I told it to measure at 600 megahertz or I told it to measure at 1 gigahertz, right? Because the 600 meg is using the third harmonic of that, and the 1 gig is using the fifth harmonic. And this is the frequency domain view of that signal. So there's the fundamental at 200, the third harmonic at 6, the fifth harmonic at 1 gig. Okay. So if you're measuring, an amplifier or a filter, you have to remember that the device is getting hit by this square wave. Okay, so it's going to be seeing the fundamental third, fifth, and even higher order harmonics. Okay, you also have to remember that the output power is not adjustable. Okay, so in the case of the H4 again, from 50K to 300 meg, the fundamental of that square wave is about 0 dBm, 0 to about plus 2 dBm. Okay, can't adjust it up or down unless you throw an attenuator there. Okay, the third harmonic is about 10 dB lower than that. Okay, 10 to 12 dB lower than that. And then the fifth harmonic, actually that's a third. The fifth harmonic is about another 10 dB further down, 10 to 12 dB further down than that. Again, not adjustable. Okay, so the question is if you're measuring an amplifier, is that the right level for the amplifier? Is it too little? Is it too much? Is it going to cause the amplifier to go into gain compression? Or if you actually want to measure gain compression, that's something you commonly do with a VNA. You can't do that with a nano VNA because you can't adjust the output power. Okay. So the channel one receive reference levels are not adjustable. It's designed to basically receive the signal that is put out by channel 0, and you can't adjust the reference level for that or the attenuation for that. So if you're measuring an amplifier, you actually have to put an attenuator in line to reduce the signal coming out of the amplifier back down to the range that the nano VNA is expecting, and then just manually compensate for that when you go and make your measurements. Okay, so relatively limited dynamic range compared to professional VNAs. As I mentioned, pretty good dynamic range, 50, 60, 60-ish dB, typically 70 dB in some cases, pretty darn good. But compared to a professional unit, which is typically 100 dB or more, it's limited. Okay, and where that might come into play is if you want to tune up a set of duplexers for your repeater, right? You might want to have 90 or 100 dB or more of filtering, in the cans for your duplexer. You're not going to be able to easily measure that with a nano VNA. You just don't have the measurement dynamic range to do that. Okay. The measurement resolution bandwidth is not adjustable. It's typically just a couple of kilohertz. Okay, and you can't adjust it up or down. So, and there may be some other things as well. So again, for 60 bucks, it's pretty amazing what you get. So I kind of call the Nano VNA kind of the RF tool or toy of the year, because like I said, for the price of going out to dinner with your XYL to not even a fancy restaurant, you can get yourself a pretty sophisticated, multi-domain RF analysis tool. Pretty amazing for what you get for, $60, $70. There's a lot of videos and things out there. Like I said, I've got a number on my channel. There's a number of folks that have produced a lot of pretty good videos. There's also a lot of crap out there, but there's some good videos on the Nano VNA, how to use it. Some very active user groups with email lists and things like that, and that you can learn from. But it's not like you can just pick up a book and read about it, because although there are some folks that have written books as well. So Again, a good U.S. source for these things because there are so many different manufacturers. You know, R&L Electronics has done a pretty decent job in making sure that the units they source have got a pretty good pedigree and they're not some cheap knockoff clone that's got bad shielding and things like that. So that's a good place to go look for them. So with that, again, shameless plug for my YouTube channel. Okay, I've got about 300 video, a little more than 300 videos. I just posted number 318 over the weekend. And that was actually comparing the Nano VNA H4, the newer one that I've got with the end connectors against a professional VNA, looking at a duplexer to understand the limitations and such with that. So anyway, with that, that's all I had to kind of present. If you've got any questions, if you want to go back to take a look at something, we can certainly go do that.
Oh, great, Alan. Thanks for a very, very interesting exposition of this new toy, basically. Something that was out of range for everyone just a couple of years ago.
Yeah, certainly.
I had one quick question about the calibration.
Yeah.
When you do a calibration, like in the morning, and you want to just store it, and then say you're going from whatever 14 to 14.3 megahertz, you want to, is that going to, what's been your experience? Does it stay put for weeks or days or hours or months?
Yeah, unless you get a tremendous temperature shift, like if you do a calibration in your nice 75-degree house and then you go and make a measurement at outside in the 30s, then it may change. But what's going to change mostly is like the phase measurement. And if you're just looking at an antenna, you don't really care. You know what I mean?
Okay.
So I wouldn't even worry about it, for the most part. Unless you need to really exactly know the input impedance so you can design a matching network. You might want to repeat the calibration, at that temperature, but it won't change that much. On a professional unit that's got 120 dB dynamic range, it'll be a bit more sensitive. For these guys, not so much.
Okay. Any other questions for Alan? I have a question for the group, and that is, how many of us have run off and bought one of these gadgets?
Shopping for one right now. Actually, I've been looking at them for a few weeks.
Okay. Yeah, it looks like Tim's got one, and a couple
Dad,
other
you haven't
folks.
got one yet?
I mean, I know on field day, it's like we've done a fair amount of antenna tuning sort of by trial and error.
Yeah.
And here's an instrument that we can have. It's got a very reasonably bright display.
Yeah.
As long
Yeah,
as they're not
it isn't real good outside, the bright sunshine. I tried using it outside once. I'm like, oh man, that really is hard to see. So, but I mean, if you put any filters in, like especially on a field day or doing a multi-op situation, you want to check the filters to be sure they're okay. I'm not sure how well it would do in a dense RF environment. If you're trying to, tune up your 20-meter antenna while somebody's banging away on 40 meters, is that going to overload the instrument? It probably will. Again, it's $60, but if you play with each antenna one at a time, and not while contest is underway, they could be in good shape.
This is Bob. I mean, Jim, Sylvia, you and I had been sort of talking about this for the better part of a year. And Alan, what you've helped with in my hesitance to make an investment was there's so much out there. And I'm one of those people that's skeptical about the knockoffs, but I never knew what categories in which to evaluate them. So there's always a tendency for amateur radio folks to look for the least expensive. And when you have everything that's named the same,
right,
and one for $60 and one for $30 and one for $150.
Yeah.
So sorting through that to some degree when you're not as versed on the technology, which you've gone just a long way in helping us with here, has been the hesitance to invest in it, but maybe might be worthwhile. That H4 looks like
I like
sure
the H4.
thing.
Yeah, the H4 is nice, and it's stable enough. I think that it's a nice way to go, and even the firmware that you get with it works great. And it was literally only about 2 weeks ago that I said, I ought to play with some of the other firmware because I never even updated it. And there's a developer whose handle or name is DISLORD, Dislord.
Mhm.
And he's done some really nice things with firmware. And the one nice thing about it is that his will bring you up to 401 points on that device.
Mhm.
So that, and a couple of other nice enhancements. Actually, I can actually adjust the measurement bandwidth on it. I mentioned that's one of the downsides. You can't do that. You can do that with the Distler firmware. So that's kind of nice. I said the other one that I just picked up about the same time period was this, the SAA2N. What I learned was actually after I posted that video, one of the developers who actually developed the hardware for the base VNA that's in here, which is really a 2.8-inch VNA, said, the version I bought is actually from this knockoff clone manufacturer that is kind of dumping these on the market inexpensively. So even though I got this from R&L, it is one that buying it from R&L is not benefiting the original developers.
Mhm.
Okay. But, I figured, well, I didn't know that at the time I bought it, but again, this was $70, so I
Mhm.
figured I'd pull the trigger on it anyway.
Sure.
Just to have something else to compare it to. I wanted something that went to 3 GHz, and I
Yeah.
like the end connectors on it. But man, it's like I said, it weighs probably 3 or 4 times as much as the little H4 does because it's got the heavy metal case on it and those big bulky end connectors. So
And where do you see the Nano VNA-F model fitting in among
so
the different range?
so within the range, I actually think the F is a better version of hardware than the H4. Okay. So the H4 is 4-inch display. The F is a 4-inch display. The F has got the metal case instead of the plastic case. It has a little bit better measurement dynamic range.
Mhm.
It's closer to 70 dB versus 60 dB. But I
Mhm.
think it only goes up to like 1 gig, right? I mean, you could tell me
Um,
for sure.
yeah, it goes up to 1.5,
It goes to
1.5
1.5 as
gigs.
well.
Yeah.
There aren't as many people developing firmware for it because there is a hardware difference between the two. But
Mhm.
I actually think the F is a better model. But it also
Mhm.
costs a little more. So if you
Yeah.
find the F, it's about $120, right?
Yeah. Yeah. That's what it was.
Okay. And but I think it's a better design. So if you wanted to get something that's better, I think the F is a better model in this kind of form factor.
Mhm.
And the other thing I like about the F is that I think I think he actually puts axis labels, like
Yes.
numbers
Yes.
on there instead of just having to look at the scale and figure it out. So there's axis labels, and he
Yeah.
properly, yeah, and it was actually developed obviously by the guy who developed it knows what a VNA is. So he calls it
Mhm.
port 1 and port 2. He doesn't call it
Mhm.
channel 0 and channel 1. Okay.
Mhm.
So
Yeah.
I think the guy who developed it knew a little bit more about commercial VNAs than the guys who developed the original Nano. So I like the F better. It was just, like I said, for me at the time it was cost twice as much as the H4.
Yeah. Yeah. No, it's remarkable.
Yeah.
I guess my frustration is one, finding good problems to apply this nice solution to. It's a solution in search of a problem,
Yeah.
uh, and then actually investing the time to put it through its paces and then do
Yeah.
some comparisons with, like, say a spectrum analyzer with a reflectance bridge.
Yeah. So I mean, to me, if you look at the antenna analyzers that we've all kind of migrated through over the years, right? I've got an MFJ 259B that I've had for 15 years. I've got a Rig Expert, AA55 Zoom. Each of those costs 3 to 5 times as much as a Nano VNA,
Yeah,
right?
absolutely,
And and
absolutely.
and the and neither of them do everything that the Nano VNA does.
Yeah,
Okay.
yeah.
So even the Rig Expert antenna analyzer is really nice in terms of it'll do at Smith charts, it'll do complex impedance, it'll do reflection coefficient, things like that. But but there's more that the Nano VNA does. However, if I was going outside to make a measurement, I'd grab the AA55 because its display is better in the bright sun,
Yeah,
okay, than the Nano
yeah,
VNA
yeah,
is. So it
yeah.
really comes down to if you think about what you're going to be doing, where you're going to be using it. But again, for $60, you give up getting pizza
Sure.
for 3 nights, and you get to spend that money
Yeah,
on a vector network analyzer. So
yeah.
I subscribe to the groups.io groups, and they are a wealth of information if you are willing to sort through it.
Yes. Yes.
So that's
Yep.
very helpful.
Yep. Yeah, you're absolutely right. It's too much information, and sometimes you'll get the snarky. If you ask a question, you'll sometimes get the snarky answers. That question was answered 6 months ago. Just search the archives. You're like, I just wanted my question answered, but then you run across that.
Point me down the right rabbit hole.
Right, exactly.
Mhm.
So, but,
One thing that I have tried, and I don't know, I didn't try very hard, but they do make a RF demo board.
Yeah.
Different signals that will,
with different loads and things like that, and different filters.
yeah,
and
like
such. Yeah.
filter things that you can really put the nano VNA through its paces.
Yeah.
Um,
Yeah, I think they even show examples of this is what this should look like. So
mhm,
that gives you
mhm.
some practice of, okay, this is a filter, it's supposed to look like this, or this is a complex impedance, it's supposed to look like that. So that you
Yep.
can practice getting the unit set up, getting it calibrated, hooking up to that device, and making sure it matches what that's supposed to look like. So it
Yeah.
is a good practice board, and those you could pick up for like less than $10 or $20, I think.
Yeah, something like that.
Yeah.
There is one limitation, and that is the connectors they're not SMA connectors. They're some really small.
Yeah, I think they use
RF
an MMCX. If I'm not
Okay.
mistaken. It's an MMCX or one of those other really tall, really small
Mhm,
push-in type, coaxial connectors that you find inside of a cell phone or something like that,
mhm,
because
mhm.
they're dirt cheap, right? It's whatever is
Yeah.
dirt cheap is what they build these things with. And that's
Yeah.
why that audio codec is what's in there, because it's dirt cheap, because it's a high
Mhm.
volume part.
Mhm.
So these little tiny push on, coaxial connectors that you find in every cell phone or, or Wi-Fi router or something like that. They're made by the gabillions, so that you can get them for, a few pennies. And that's why they make these kits like that. But I wonder if anybody's actually made a kit like that actually has like SMA connectors on it. They cost more,
Well,
you know?
yeah, that would be useful.
Yeah.
I'm finding that because these little connectors are for me hard to push on,
Mhm.
and then they are easy to not have a good connection.
Yeah.
So that's
How easy
gonna,
would it be to solder a new one on?
Yeah, yeah, you could probably get one of these boards, and if you're careful enough with an iron, probably hack in SMA connectors on it, and then just
yeah,
use it that way. So
yeah,
What
yeah.
that
So
leads
that's
to is the need to have sort of a group of connector and gender changers
mhm.
for the equipment that you're trying to assess, the DUT that you're trying to assess.
Yeah,
You're going to need a lot of
sure.
different conversions and
yeah,
calibrations.
yeah. Just to show you,
Well,
I'm gonna reach down here. I disappeared here for a second, but I'll show you why I did that in a moment here. So you wind up when you start getting one of these things is building little fixtures like this, right? So here's
yeah.
one where I can plug in devices that I want to measure, and I can measure either reflection properties or transmission properties. I got a handful of little RF adapters that connect to different types of, connectors and things like that. So you wind up building these collections of things. Like I've got one here that this is. Let me see here. Let me hold this up. Here's an SMA, female connector with just a pair of socket pins on the other side of it. So I can stick a
Mhm,
component in there and stick that on the VNA and go make a measurement on it. So you wind up
mhm,
building all these little things to go. And then here's the same thing with the connectors on the socket pins, but the other side is an SMA male instead of an SMA female.
mhm, mhm.
So you build all these little widgets, to make use of the tool. So,
Yeah,
One of these
yeah.
is like the others.
you know,
Well, that kind of is a nice segue into another commercial for the mini Hamfest this Saturday, and that is there's a box of UHF adapters, like PL259 to BNC. There's a box of BNC adapters, and then there's a box of even F connector adapters, and those are going to be at some very modest price of whatever. I guess I'm not supposed. I forgot we're not on the air, technically. So I guess I can give some,
Plug away.
but they'll be reasonably priced
Okay.
to sell.
Yep.
And lots of them. It's absolutely remarkable to me how much one individual can collect over a very nice long lifetime. Um, anyway, it's been quite an experience to sort through this collection and make sense out of it.
Right, right.
And it's funny, the smaller the item, the more valuable it is.
Yes. They're the ones that are easier to lose. So you always got to replace it again.
Yeah, yeah. So,
Just small packages.
That's right.
yep, yep.
But-
Any other questions for Alan?
Yeah, I guess the other thing I'll say is I know some of the same guys have developed what they call a tiny SA, which is a small spectrum analyzer in the same form factor. I don't have one. I've never played with it, but it's also about that same $50 price range. I think I've only seen it in the 2.8-inch display version right now. But obviously there's going to be some severe limitations compared to a real spectrum analyzer. But what I'll also say is that if you're looking to just do basic spectrum analysis with limitations, you can often get away with one of those little, RT, SDR, RTL, SDR,
Yep.
USB receivers, and then people make software that make it look like a spectrum analyzer instead of receiver. So.
Sure.
But
Sure.
there's this tiny SA is supposed to be a pretty fun little thing too. But again, I don't have one of those, and I've got enough spectrum analyzers here that I don't.
Yeah, you got the
probably
right
won't
thing.
be picking up one. So
Sure. No, the SDR Play or SDR Uno, they've done a very nice job. In fact, that was really my first exposure to a affordable spectrum analyzer. I was
there you go.
so shocked at what $200 at that time, a couple of years
Right.
ago, would buy.
Sure, sure.
Little did I know that the Nano VNA was right around the corner.
Yeah.
And,
Yeah, and I think that it's something because it's all open source and there's not one manufacturer. I think, and I've also learned that the folks that did the V2, this one here, they're working on a new version now that will be a 4-inch display, have a larger number of trace points, adjustable measurement bandwidth, faster sweep speeds, things like that. So this is going to keep changing. So and what you get for your money is just going to keep getting better and better. So I don't think you're missing out if you wait. I don't think you're missing out if you buy it or if you get something now, because they're all useful things, and it's just going to I said I play with these for a year or so, and then we'll see what's out there. It might be a 6 gig unit that's got 80 dB dynamic range that I might say, oh, go pick up one of those and give one of these to one of the guys in the club or something. So.
yeah, sure. Sure.
Is the software process of upgrading the firmware from a PC pretty straightforward and risk low?
Yeah, so on the H and H4 is the only one I can comment on. Well, that one and the other one, but I can't comment on the F because I've never done it on the F. But on the H and the H4, the firmware is loaded in Flash. So you from what I've been told, you can't brick the unit. Okay, so the worst you might have to do if something gets messed up is to open it up, and you have to bring it up, and you bring the unit up in what's called a DFU mode, like a programming mode, and there's a way to do that by holding a button down when you turn it on. But if you can't do that because something happened, you open it up and you short 2 pins together and bring it up. And once you have that, then there's just a tool from ST, the people that make the microcontroller, that you basically load the tool up. If you brought this thing up in this DFU mode and hook it up to USB, the tool recognizes it, and you basically point the tool to, I want to upload this new version of firmware. You load that, you pick it, and you say upgrade. Done. It's really, it takes 30 seconds, not even. Okay.
I can vouch for that. I did that with the original Nano VNA that only went up to 900 megahertz.
Okay.
And then when the upgrade came with new firmware to bring it to 1.5 gigahertz,
Yep.
I did have to go through that process, and it was not bad at all, especially just Windows 10.
Yep. Yeah, and the SAA2, this one here with that goes to 3 gig. That update process is a little different. They've got one of the offline piece of software that uses this called Nano VNA QT. You do the firmware update right through that, so it's even easier. Okay.
Yeah.
So, Yeah.
And the big fear is bricking it. And so
Yeah.
you said that that is a
The
lower
risk of
risk
that
than.
is, yeah, the low risk of that is minimal. I've only going through reading some of the messages that come through in that groups.io. There's only been one instance where I saw somebody, they thought they bricked it, but then by going through the process of booting it with the, with the those pins shorted, we're able to get it sorted out and working again. So I don't know that it's virtually impossible to really brick it. So
Yeah, that's encouraging.
yeah.
Also, these batteries are very, very powerful in terms of long,
Yeah,
long life.
they use the lithium ion batteries. The very initial ones that came out a year ago, the battery controllers that were on them weren't that good, and then some people reported that the batteries were ballooning up because the charge controllers weren't working right.
Mhm.
In the H version, the H4 and the SAA2, they used a much better charge controller for the
Mhm.
lithium ion batteries. So I haven't had any problem for the several weeks or months that I've been playing with them.
And it charges through the USB port.
Charges through the USB port, so you can either leave it plugged into your PC, or if you have, everybody's got a dozen USB chargers for their iPhones to everything else.
Mhm.
Just anything that's got a 5-volt USB plug on it, you plug it in, and it'll charge. So.
Yeah.
And
Wow.
I know on the Nano, right where you plug in, that there's a little tiny little red LED that I think it flashes when it's charging. It glows continuous red when it's done, or it's on and then it turns off. But it's obvious a change of when the charge is done. The SAA2 is a little bit different. There's actually 3 little holes on the back of this you can't really see because it's all black here. Actually, if I turn it on, you'll see. Let me see, where's the switch? You see those little LEDs there.
Mhm. Sure.
When all 3 of them are lit up, there's another one in the corner here. Then I've got full charge. When it goes down to just one being lit, then it's down to essentially almost being out.
Mhm.
But that's the way that one's done. So, but
Mhm. Sure. Mm. No, um, that's, I mean, really, the display here is the size of a really expensive iPhone.
yeah, yeah,
So that's something that we're pretty used to. I
yeah.
mean,
Yeah, this one,
this,
this has got that Dislord firmware on it. And again, I don't know how well the focus is working on this, but you can see that it's actually showing that it's 401 trace points at different measurement bandwidth. So that's one of the things that you get with this version of firmware. So it's kind of nice. So
mm, yeah, um, that's uh, the sky's the limit. I mean,
yeah, yeah.
uh,
But like I said, if you play with any hardware at all, or like I said, if you just want a $50 antenna analyzer, I mean,
yeah,
and that's all you ever use it for, then that's still a bargain compared to, even some of these other ones that are out there now. As much as I like the Rig Expert, and even the MFJ, I used that for years. It's hard to beat these things.
mhm, mhm. Yeah, goodness.
In that specific example you gave, Alan, comparing it to the MFJ, do you get as much functionality and confidence in the results of the Nano as you do in the MFJ, which is pretty highly rated?
I have thus far, in terms of when I've used it, to me it's easier to get the result because like the 259, you're measuring at one frequency. You got to rock the knob back and forth if you want to actually trace something out, right? Where with the Rig Expert, it can tell it a frequency range, but that costs $300, right? The 259 didn't cost quite that much. But to measure at a particular frequency or measure over a frequency range, I think the results I get in the Nano VNA are as good or better than, because you get kind of more information. You can see, I can see a sweep over a frequency range very easily. Say, oh, my resonant point's over there. What do I got it? And if what I've done with it, and it's really handy, is I run a non-resonant dipole here. I've got a relatively small lot, so I've got a 135-foot dipole that's just barely squeaked between my neighbor's houses and mine.
Mhm.
And then just fed with 450 ohm ladder line down into I use a 10-tech 238 tuner. Okay. And what I do I build a little tuning chart. So I know if I'm going to go to 40 meter CW, I need to set the dials to here. But the way I do that, instead of actually transmitting and doing that, I put the Nano VNA on there, and I
Mhm.
take a look at the charts. I look at the Smith chart, and I look at the SWR. Okay, and then I'll set it over the frequency range that where I want to tune it to. take a look at the nano VNA and adjust the knobs. And with the Smith chart up, because you're looking at the input impedance, you'll see the effect of adjusting, the capacitors and the roller inductor, and you'll see which way that's moving the chart around. And you almost get an intuitive feel that, oh, I need a little more capacitance here, a little less inductance there to slide the chart around where you want. Watch the SWR come right in. So I do that on all the bands I want to tune my antenna to, write all them down, and I keep that little cheat sheet, next to the tuner. So it makes it easy for me to go set up for whatever band I want to operate on. But, rather than having a single point measurement, it gives you a lot, you can see where you are and how to move things. So I think it's a little more intuitive ultimately than you get with like a 259.
I can see a Smith chart tutorial in our future, Jim.
Oh, yeah. Yeah.
If any of you can remember it, I can't remember it from college, but
Yeah,
I have a couple of plastic ones that I have used.
Yeah, I've got a couple of videos on my channel on the Smith chart. One of them is actually a recording that I did after the fact of a presentation that I gave on introduction to Smith chart to a microwave group down here about 2 years ago. But then I've also have a couple that kind of, there's even one that's entitled like visualizing the operation of an antenna tuner using a VNA and a Smith chart. So that's another video there. But I'd be happy to go through kind of the basics of Smith charts just so you understand what it does, and what it represents. So it's not a complete mystery.
Yeah.
To use that thing,
Oh, say it again, John.
to use that as an antenna analyzer, do you only use port 1 on it?
You do. Well, you only use port 1, what the nano VNA calls channel 0. That's all you use. The other one you can just ignore. And you can choose to just have it sweep SWR versus frequency if that's all you want it to do. You might, if you're looking at like tuning a filter, oftentimes you'll have a much sharper notch you might want to tune. Then it's usually more instructive to actually look at the log magnitude response, because you'll get a much sharper response of where the resonant point is. But whatever you're comfortable with, SWR or log magnitude of S11. And then if you're, again, tuning an antenna, I find it helpful to have the Smith chart up to see how the curve moves around, but you don't have to do any of that. You can literally just do SWR versus frequency, and that's it. At a third the price of a 259B,
Yeah.
So.
Yeah, right. No, it's amazing. The other thing is interface. I mean, if you've got a laptop, you get, as big a display as you want, basically.
Yeah.
And there is some nice PC software for these.
There's a couple of varieties of that too. Now, in my case, where my shack is, I don't have a PC anywhere near my computers or my radios, because I don't do JT8 or any of those things. I'm just kind of a CW and sideband rag chewer. So in fact, I do all my logging on paper, and then later on I bring it to the computer and put it in an electronic log. So I'm just,
Sure.
the radio is just the radio for me, So
Yeah, beautiful.
For Bob's benefit, I have the Model F, and I have updated the firmware on mine. With the Windows 10, I think, has a built-in driver. So as soon as you plug it in through the little mini USB connector, it mounts on the in Windows Explorer, and you just drag the firmware update into the window of the Nano VNA, and then you power it on and hold the button I think it's the wheel or the button at the same time. It automatically looks at the file and upgrades automatically.
Even easier. That's perfect. Yeah,
It's
really good.
Very easy to do.
Yeah. I don't know if there's as many people, other developers developing firmware for the F other than the person making the F. But like I said, I think the F was very well done, and I don't think you can go wrong with that one. So.
Well, another advantage with the F, I mean, I'm partial to the F because I own it. The owner, the guy that developed it, is very active in the F user group on Facebook.
Ah, okay.
So you can speak to the horse's mouth.
Yeah. So hey, it would be nice if you add this feature, and if other people chime in, he'll probably do it.
He encourages that, as a matter of fact.
Oh, that's great. Yep. So you kind of get what you pay for by spending twice as much for that.
And oh yeah. And,
Yeah.
and you can actually, there's an app for a smartphone too.
So
Mhm.
you're gonna make me go out and buy an F now too.
So if you don't have a PC with you and you have your phone with you,
Yeah.
you can interface it to your phone.
Oh, cool. Very cool.
Go out and buy one, Alan, and send the bill. Send the bill to Tim.
Well, the good thing is I can buy things and write it off against my YouTube channel. So.
Oh, yeah. Sure.
To what degree is
Okay,
there
get
Mac
one of
OS
them.
support? Is there Mac OS support to any degree for these devices? You know,
Um,
if you have a MacBook Air, I'm not
Yeah.
looking at it from a home situation as much as if you're out in the field.
Yeah.
Sometimes the MacBooks are just easier to manage portably.
Yeah, I don't know personally. I would assume that obviously if you ran some kind of a Windows emulator, a Windows virtual machine, then I think it would probably be fine. Whether it works with Mac OS and there's utilities for Mac OS, there may be. I just don't know. Now,
Mhm.
I know
Mhm.
most of the developers will also publish the source code. So if you are of the type that does programming, things like that, and you know how to compile Python code, you could just compile it yourself.
Mhm. Mhm. Yeah. Gee. No, that it's limited only by one's hours in the day and who has
Yep.
who has asked the right question.
Right, right.
It comes back to an acronym that I've shared with SARA people in previous presentations, SMOP. Anybody remember SMOP?
Yes, I do.
Yep.
Simple matter of programming.
Everything in the world is SMOP.
Yeah,
Yeah,
just,
yeah.
in other words, blame it on the programmers.
Yeah, I used that acronym within the last week. Bob, just give you some credit. Wow. The YouTube videos I find absolutely ideal for my level of understanding of technology, electronics, and so forth. I have probably watched 50 of Alan's YouTube videos. The first of which was about how a spectrum analyzer works, because I had just gotten into the spectrum analyzer world thanks to the SDR and so forth.
Yeah, so maybe what I'll do here is well plug my channel since you kind of started, Jim. So, but yeah, youtube.com/my call sign W2AEW. And the reason I wanted to bring this up is because, as you can see, the last couple of videos I've done, this is one comparing the nano VNA, measuring a duplexer with a professional VNA, the port extensions, measuring coax length, measuring a low pass filter, etc. What I wanted to show you is that since I have 318 videos up here, one of the things I wanted to point to, the fact is right over here, you see that says video index PDF file. If you click on that, it actually brings you to a PDF file of every one of my videos.
Yeah.
And they're all links. And the first part of the list is numeric. And then after that, it's listed by topic. So you can, and it's a PDF file, you can search it. Every one of these is a link. So it'll help you find things. You can also do a search right here to search for something. You click on videos, it just goes to a list of all the videos. Okay. But they're all, in the neighborhood of, 5 to 10 minutes long for the most part. Some are longer. But I try to keep them short and sweet, no fluff, no screaming and yelling like that crazy Aussie guy on the EV blog.
That's the signal path.
Oh no, Signal Path guy is really good. He does some really long videos, but
Yeah,
Shariar,
that's right. Different. I know who you're thinking of.
yeah, the Signal Path guy actually lives 2 miles up the road from me here. And I've been to his lab, and it looks as impressive in person as it does on his videos. But he's a brilliant guy. I was thinking more of the Dave Jones, the EV blog guy down in Australia.
Yep,
Yeah.
I've seen him too.
Yeah, but
Well, when I first was just looking around, in the big World Wide Web space of YouTube videos, I saw one of Alan's videos. I thought, finally, this is something I can really understand, and it was so clear. And little did I know that maybe 6 months later, I met Alan during a demonstration of some new spectrum analyzers at Union College. And it was like, oh, It took me a little
I
while
know
to
you.
make the
I know
connection.
you. You're that YouTube guy.
Yeah.
When my bench looks like that, it takes a day to clean it up.
Well,
Then
that's
my
the thing.
then
Well,
my
it's
wife comes in. Then my wife comes in and asks me if there's a contest coming up.
Well, the thing is, I normally am out on the road, like I said, going to see folks like Jim and doing things in person. But ever since COVID hit, I haven't been out to visit a customer since the beginning of March. So
Wow.
all the equipment that I normally will have with me in my car to do presentations and demonstrations and seminars and things is all sitting right here. So
Wow.
I can basically power everything up. Got it all set up through my network. I can take the display of any one of the pieces of equipment and display it and do all my demos remotely. So
Nice. Gee.
No, I was talking about I was talking about the display on the top of that web page we were showing.
oh, well, that's how my workbench looks all the time. So
Yeah, that's what I say. I clean mine up once in a while, and I get accused of a contest coming up.
okay. Well, the thing is, my my office is in one place. Upstairs in a spare bedroom is my shack, which is the radios, and then downstairs in the basement is my workshop where I do all my
Wow.
videos. So it's I got stuff sprinkled all over the place.
Yeah, man. There was one other video that was extremely helpful for me personally, and that is one on how to basically redo a Drake
Oh, the 2B.
R2B receiver.
Yeah.
I've got the R4B. It's
Okay.
actually the college's, but wow, I pretty much followed in Alan's footsteps through the recapping, repair, and then the alignment.
Yeah.
Oh man, that was very valuable.
Yeah, that was a fun set. It's funny because another audio podcast that I like listening to, and anybody who does any home brewing is probably familiar with an audio podcast called Solder Smoke. And a guy named Bill Mara is down in the DC area, and another fellow, Pete Giuliano, out in California. They do about every couple of weeks, we'll do another audio podcast. They talk about home brewing and circuits and other things like that. And I've been listening to them for years and years. And Bill always talks about when he was a novice as a kid, that this Drake 2B was like this cat's meow, and he still has the same Drake 2B. And so he always was praising the Drake 2B. I think he just drove the price up of all these Drake 2Bs that were out there. But I wound up finding one at a ham fest for like $50 that needed some work. I was like, that looks like a good project. So that's how that came to be in my shack. So in fact, if we go to, let me see here, let's go to my virtual backgrounds and I go to my shack here. There we go. Oh, actually, it's not in that picture. Okay, the 2B is actually sitting right here where that FRG7 is. That's where the 2B is now, but it's not in that picture. So
Well,
I don't know if I have a new one or not.
The series on taking the 2B from as received to extremely, essentially showroom quality. That's quite a instructive set of videos.
Yeah, the camera lies. It's nowhere near showroom quality. The camera makes it look a lot better than it really looks. It works. It was a resurrection, not a restoration. So
yeah, that's right. That's about it.
Yeah.
The one other quick thing was in that early video about how spectrum analyzers work. Alan was displaying a Tektronix 1401A spectrum analyzer, and just to sweeten the pot a little bit for the Hamfest, there happens to be a 1401A spectrum analyzer from Clark's collection of gear. When I saw that unit on his bench, it was like, wow, what a nice way to close the loop. I took it home and played with it for a while, and it does. It needs work, but it does do a display, and it is a cute little unit from probably, there we go.
Yeah, that's the video. It's video number 22. I did that 9 years ago.
Oh, man.
Let's see,
Okay.
day before my birthday 9 years ago.
Oh, that's
And
too
it
bad.
basically
Yeah.
just talks about how an analog spectrum analyzer works and happens to feature the 1401, which I had just picked up at a Hamfest
Yep.
2 weeks
Yep.
before that. So yeah.
So here I saw this video and I just heard Alan's voice. No picture of Alan at all. So here I was expecting to see a gentleman with a button-down blue shirt, sort of like mine, but no pinstripes, and just sort of taking a day off from his professor job, and so anyway, that was what went through my mind.
Yeah.
But it's a very worthwhile video to watch just to get the basics of how a spectrum analyzer works. And with that 1401A, it does have that matching Sony Tektronix oscilloscope, which
Yeah.
also could use a little bit of work.
Okay.
But anyway, that was just like a I don't know, just a wonderful thing to see after seeing your video. I don't know how well those sold, but they must have sold somewhat because they were really the first real portable.
That was the thing, is that at the time it came out, we're talking I guess early 70s. That was probably it was sold a lot to like the surveillance community, because it was really a lightweight, relatively lightweight and portable spectrum analyzer in the days when a spectrum analyzer was a big 19-inch rack, 20-inch tall instrument, so but it only went up to 500 megahertz. But for doing surveillance of just RF and things like that, and looking for bugs and things like that, it was kind of a nice tool for that.
Yep, yep. No, it's just an amazing thing.
Yeah.
So I don't want to hold everybody all night, but I must we have sort of a tradition of giving our speaker a honorarium, and this is for Alan. It's a
Nice.
K2AE. That's our
The club.
our
Yeah.
club repeater name.
Oh, nice.
And I will I can't email this to you, but I will
No.
send it to the real mail.
No, I appreciate that. Thank you.
So we really appreciate your taking the time to share with us.
That was my pleasure.
And,
hey, one more plug I'll put out there too is, I don't know if you're familiar with, there's a weekly amateur radio club roundtable, or amateur radio roundtable program that's run every Tuesday night, 9 o'clock Eastern time, by a W4KUB. He streams it live. It runs for a couple hours, but a few weeks ago he asked me to become a regular part of it. So I'm actually one of the co-hosts, if you will. We do a segment called Tech Tips. That's you go to w5kub.com and you'll see the link to watch the live video stream. And like I said, it's starting every Tuesday night at 9 o'clock. Feel free to join in, but it's usually the host, Tom Medlin, then myself. We'll usually have 3 or 4 other people on that will cycle through and talk about various topics. But I think what we're going to try to do, at least for the tech tips segment, is a little introduction to oscilloscopes in terms of what they are, how to use them. Probably spend just 15 or 20 minutes talking about that, as well as the other things that everybody else on the program is involved with. But so just something else. You got nothing to do on
you brought
Tuesday
up
night.
that call sign. Are they the group that's launching a balloon?
Yep. Yeah. Tom is also the guy that does some balloons. They just launched one on Saturday.
That's where I saw that. Okay.
Yep, the same guy, and so I'm sure he'll talk a bit about that during tomorrow's program, because he just launched one Saturday. The last one didn't fare so well. The one before that went around the world 3 times.
What frequency are they?
I'm not well. Good question for him tomorrow. I know they were doing APRS. I'm not sure at what frequency. They were also sending out beacons on Whisper. And I think I think they're doing Whisper on 20 meters. So you just have to look for W5KUB I think it's W5KUB-19 or something like that. It will be the balloon, and I think it's currently it was just west of Morocco a couple hours ago, and they expect when it wakes up tomorrow morning, it'll be somewhere over the Mediterranean, kind of heading towards either Italy or Greece or something like that. So.
Mm. Wow.
Yeah, I was on the website earlier, and it was
Yep.
couldn't really it wasn't really accessible for a screen reader.
Yeah. Okay.
Mhm.
Yeah. So he'll be there. You know, I said I'm sure we'll talk about that tomorrow night because this has been a couple of weeks in the making to get that one up in the air. So.
That's great. That's I had not heard of that yet, so that's good good information.
Yeah. So like I said, if all the reruns are coming up on Tuesday night, you got nothing else to do. There you go. So,
Oh,
It
man.
would be better if it was Wednesday night this week.
well, and also they were simulcasting it on WBCQ on 5130 on shortwave, but WBCQ had a problem with their 5 megahertz transmitter. So now we're going to be simulcast on 6160, but it's going to be delayed. Like they're going to start it at 10 o'clock, and it's going to be the recording from the previous week.
Mhm.
So, but it's just the audio at that point on shortwave. But that's kind of fun too, to be able to tune in shortwave and hear your own voice, you know.
Sure, sure. No, that's great. Any other comments for Alan or any other thoughts?
Yeah,
Well, I know you're
something
about
else-
to do it, but Alan, thank you.
Oh, you're welcome. Like I said,
A big
feel
thank
free
you.
to join the channel or look at the YouTube channel. If there's videos that you'd like to see, you know, shoot me an email. It's w2aew@arl.net. There's a topic that you'd like to see, shoot me an email. If I've got something on it, I'll send you the link of what I've got. If I like the idea, I'll do a video on it. If it's not something that interests me, I probably won't do it, to be perfectly honest.
Okay,
So, but
sure.
it's just, you know, it's just a matter of, I've got a list, you know, a couple of hundred topics long that, depending on what interests me at the time and what I've got time to do, is I try to do. But what a
Yeah.
lot of people don't understand sometimes is that, you know, for every minute of video represents, you know, 30 or 40 minutes of time, you know. So
Yeah. So what do you do with your spare time?
what spare time?
Yeah.
Edit
that's-
videos.
That's where I was
Yeah.
headed.
Yep.
Yeah, no, it's and I must say Alan does respond to emails, so you know, don't be bashful, guys.
Yeah.
So
Well, thanks for having me. I enjoyed it.
oh yeah, well, this is great. I sure appreciate it.
Thanks for doing this. It's probably going to push me over the edge to finally make a purchase I've been drooling over for a couple of weeks.
Oh, sorry about that.
No, it's good. It's good. Information is good in this case. Like but like you said, there's just an ocean of info out there and a lot of crap offerings and some good ones, and it's hard to differentiate. So this is more useful information than I've
Okay.
had. Thank you.
Great. Sure.
It's too bad you don't get a little piece of the action there, Alan, on
Yeah,
all
I know.
the potential sales that you may stimulate.
Yeah, I don't know. I know RNL sold out of that SAAV2 very shortly after I put that video up. So.
There you go. That's useful information. Great. Okay, gentlemen. Well, until next month. Well, we'll hopefully see some of you guys Saturday, and Alan will certainly be in touch in the future.
Yeah, any questions on that RSA, let me know.
Very good. I sure
Okay.
will.
All right. All right.
All right.
Take care, everybody.
See
Take
you
care.
later.
Thanks.
Thanks again.
Thank you.
Thanks,
Thank you.
guys.
Thank you.
Hey, Jim.
Peter.
Yeah.
I was hoping Peter wouldn't leave.
Thank you so much.
Is my audio on, Jim?
Yeah, I hear you.
For those that may not have known about it, did you want to make another announcement about the mini handfest?
Well, almost everyone's gone, but yes, by all means, Saturday morning from 8 till 1 at Skip Evans's house, 30 Pinewood in Scotia. We're having a ham fest with two estates. Clark Gittinger's, who has one of everything, And the Jasinski estate, what's left over from the earlier mini Hamfest that Tim has organized. So pay attention to your email. The inventory of both estates is listed in some graphic detail. And as Tim said, there is something for everyone. So you will not go away empty-handed. Well, good, but probably isn't going to happen. So, and we don't want to take, we don't want anything left over. So we're there to satisfy your needs for good stuff.
That sounds like price to sell.
You said it. You said it. How's that for a shameless advertisement?
All reasonable offers will be considered.
That's it. Yep. Cash accepted. I guess we accept checks, but cash preferred. Cash on the barrelhead. Yep, it'll be fun. Check that inventory, and as Tim said, please no early birds. It's want to give everybody a fair shake, and feel free to pass the word.
And I might add, some things that we'll have available, it's not currently on the inventory, like drawers full of parts and nuts and bolts and stuff like that.
Yep. Lots of stuff. Too many things to list. How's that? If you need
I'm surprised you didn't buy that oscilloscope.
I wish it was closer.
I'm on this. It's on my short list. It's definitely on my short list, but I thought I'd at least give everyone else a chance. I've got some oscilloscopes as it is, but there's a 475A and that nice little pair 1401A spectrum analyzer plus the 323 oscilloscope that goes with it. And then there's a couple of large mainframe oscilloscopes, 7603, which only presents a dot, unfortunately. I haven't been able to spend enough time with it to do any troubleshooting, but we don't have any horizontal or vertical sweep, but we do have, high voltage, and the CRT is good. Then there's a 7704, and the one with a dual beam CRT and one with a single beam CRT. Those I think are all the scopes. Oh yeah, no, there's also that Ismatec. No, wait a minute, that's not right. Instec, yeah. One of the early digital scopes that came out. And that was essentially new in the box as I picked it up from Clark.
I've had three Tektronix scopes for 40 to 45 years, and they still all work flawlessly.
Wow, that's good news.
Cheap plug, Alan. Sorry.
I can't remember what model I've got in the cellar, but yeah.
Yeah, well, let's see. Well, have you seen? Let me pull up my basement.
I can't remember
here.
the model number of what.
Holy cow!
Yes, there's the scopes in my my basement lab. So
yeah.
So
Jim, you got some catching up to do.
Yeah. I've got a nice 2465 in my shop.
Nice.
And
we talked about that one, I think, right?
Yeah.
I've got a 65. I got a 65, a 67, the 485, and then the 465. And then all the way over on the right hand side, you can see that's a 576 curve tracer.
Man,
I can't remember the model lines of the ones that were very large. Like the front face dimension was 18 inches, maybe by 24, and they had modules that you plugged in and out.
Yeah, those were some of the old
lower
500
right.
series. Yeah.
Yes, those big ones. Yeah, we had one in grad school, which was I think a 545, and that got me through grad school.
Yeah, that number is connecting some neurons. Yeah.
Yeah, 4-channel. What plug-in we had, and it was heavy duty, you know, serious vacuum tubes, but as reliable as you can, you know, get. It's probably still working somewhere, but
I have a 465 that I've used very little, but it still works like a charm.
Yep, that's one I've got all the way over on the left-hand side of my picture. There is that's a 465B on the cart there.
Yep, yep. So yeah, it's and I see the Simpson 260.
Yes, that's one of 3 or 4 of them I've got. So.
I was raised on the Simpson. Well, actually, the Simpson 260 was the Cadillac when I was a kid.
Oh yeah.
And most of the time, I used my dad's vacuum tube voltmeter Heath kit. If anyone has a tendency for nostalgia, there's some very early Heathkit signal generators, an audio generator and an RF generator that we had. My dad built before I was able to walk, basically, maybe before I was. And so anyway, a lot of generations of gear. There's a boat anchor of a serious nature. It's a Johnson Viking 2 that I have a hard time lifting.
Yeah, you probably need 2 people to lift that one. Yeah.
But the great thing about the Johnson equipment, as you and I have talked about, because I have a Valiant, and it had the most rock stable VFO ever. I don't know how EF Johnson was able to do that at the price range back in the 60s for those devices. But boy, if you wanted something, you know, I mean, there was the Viking 2, the Valiant, I think it was called the Invader. It's probably 4, 5, 6. And that was that motif of dark. Remember, it was dark maroon and dark gray with green accents. And boy, they were successful. I hesitate to fire up my Valiant without doing the preliminary replacement.
Well, you know, we do have another plug. We have about I think about 6 Variacs for sale.
Yeah, I actually have a couple of Variacs, and absolutely, okay. Jim, that's the way to do it.
Yeah, just take your time but honestly,
the other thing is finding 6146Bs. There are 5 of them in this unit, 3 in the final amplifier and 2 in the modulator. And then it used those gas discharge tubes for the high voltage amplifier. I can't remember the numbers. 855, is that 866? But anyway, in order to refurb it, it will probably take quite a bit of dollars to find the key pieces. So,
well, yeah, for capacitors, there's a good old Hayseed Hamfest. They will either do custom or they have some, you know, for example, if you want to recap a R4B Drake or even the R2B, I think they have a pre-packaged set.
That's where I got the ones when I did my 2B from Hayseed.
Oh, what a great idea. I was unaware of that, Jim.
Yeah, the nice thing, you just tell them the model number, and they, like even the multi-section caps that have got multiple caps in one can, they rebuild those in a similar can. So when you replace them, it looks like original, even though it's got modern caps inside the can.
So they would fit right in the chassis punch out that was.
Yes, absolutely. Yep, I've done that a number of times. I've been very happy with Hayseed Hamfest. I did it for this Drake, and you know, it's a very reasonably priced, you know, way to upgrade a aging receiver or any piece of aging equipment.
I've heard lots of good things about them from the different Facebook groups and so forth.
Could you repeat that reference? What was the name of it?
It's called
Hayseed.
Yeah, Hayseed, like someone from this country. Hayseed Hamfest, 2 words. And just Google them and you'll see their webpage and
spell it.
Hay like hay, S like Sam, Echo Delta.
Oh, I'm glad that you spelled it because that's not what I wrote. Okay.
Oh man, okay. Yep. Hamfest. So yeah, that has even hi-fi gear. I've got two old 1960s receivers. One that I bought new in '62, and just for safety, it's a very the right thing to do to recap. Um, so yeah, it's one thing to bring these old units up slowly on a variac, but if you're going to use it, day after day, week after week, I would suggest recapping and having that out of the way.
I refurbed an old DX60, a Heathkit DX60. I did not know about Hayseed Electronics at the time, and the DX60 has a multi-section high voltage cap.
Yep.
And I removed it. I cut the bottom of it off with a Dremel tool.
Yep.
I removed the guts.
Yep.
And I replaced the guts with discrete new capacitors.
Yep.
And I wired it up, and then I epoxied the bottom of the cap back on.
Yep.
And put it in and reinstalled it in the DX60, and it works like a charm, and it has the same look and feel of the old.
Beautiful. Yeah.
I just took a look at their website, hayseedhamfest.com, and looks like their facility, or probably the guy's house or the neighborhood, got hit by a hurricane.
Yes. Right.
Or a tornado in the middle of August 10th. And they got some really destructive pictures here, but it looks like says they're back making caps again. But if you go to hayseedhamfest.com, you'll see that.
Yeah, I saw that. It was shocking because it seemed like the tornado went right down their street and really nailed them. But they're back up and running.
Yeah, Sabo, that's it. What you put on the chat, that's the right place.
See, whenever you sit back and say, "What was
blew
me
the caps
about?"
off?
Say it again.
It blew the caps off his house?
I don't know really the extent of damage to the actual factory or shop, but it was, at least in that area, the area was pretty hard hit. What Tim was saying about the restuffing, I did that to a Zenith Transoceanic before I heard about Hayseed Hamfest. And it takes some time to do the stuffing and re-epoxying. It's satisfying, but it does take time. So anyway.
Unfortunately, they don't have any biking equipment.
Well,
there,
they
but
do.
I've done a similar trick with rectifier vacuum tubes. You can take a soldering iron and hook up wire to a Weller gun type soldering iron, and you can hook up wire to the terminals, and you can wrap the wire around the base of the tube, and by heating the glass and then dunking it in cold water, you get a perfect break. And then you can take it out of the vacuum tube and replace it with diodes.
Diodes, yeah.
And then you can glue the glass envelope back on the top. And you have a solid state replacement. Again, you maintain the same look and feel of the old radio.
Yeah, just you have a much lower forward voltage though.
Yes, you do. You have to insert resistance.
Yep.
Otherwise, you're too high.
Right.
Good point. Yeah, that's good stuff.
Or then you can take the throwing everything into it, which is what I did tonight with that power supply that I was powering my 2-meter rig with. I haven't turned it on in 20 years, and I just said, well, let's see how the circuit breakers are working in my house. And the end result is I got 14 volts out of it, but apparently with considerable hum. So I'm going to have to get the Tektronix scope out to find the hum in another device. So
You got 7 volts of ripple.
Could
Yeah,
very well
right.
be. It could very well be. I'm
Yeah.
hoping it's something simple. But
Well,
hey,
we
a
had a
little off
lot of
top,
fun.
a little off topic. I just wanted to ask Stanley, what kind of camera are you using? I'm just curious. The picture is really very, very impressive. It's sharp and at both near and far focus. Stanley, I'm gonna stop you because it sounds like you have an audio processor in there that's changing into Mickey Mouse, and I don't know. I couldn't understand it. Could anybody else?
So
Camera's great. The microphone sucks.
Okay,
so,
no big deal.
yeah, that's a challenge. It is. So Stanley, yeah, you're coming out like one of the 3 chipmunks. I don't
Yeah.
understand why. One of the fellows said just unplug the mic and plug it back in. Maybe, I don't know if it's.
If you have a USB mic, that may be
Yeah,
worth a try.
yeah, that is
Unplug the mic and plug it back in.
that's the first I've heard of that symptom.
Yeah.
He's inhaling helium.
That would be it.
Yeah.
Looks like his camera and his mic are one. When he unplugged it, we got lost.
Unlike me, Tim, who's inhaling something else, but let's not go down there.
Let's see. There was one other thought.
Stanley, if you can still hear me, I didn't want to throw you off. I apologize. I didn't realize there was a problem. So
the camera was super.
Yeah. No change. Beautiful picture.
Yeah, same problem, Stanley. I don't know. Wow, that's a challenge. I don't know. Like for example, Alan, I know you're in a lot of Zoom conferences or tech or whatever Microsoft team.
Yeah,
I don't know.
Teams, Zoom, WebEx, all of that. I haven't heard a voice changing to Mickey Mouse like you did there, Stanley.
Yeah.
Sorry.
That's what I was going to ask.
New one. It's a new one for me.
Yeah.
Oh, wow. Sounds like another project.
I think the typical Windows fixes to reboot and start over again.
If he speaks slower.
Stanley, in a
compensation.
in a constructive way. I know you can't respond other than with your smile, but I'm sure I'd be happy to work with you offline. I'm not a Zoom meeting guy because of security issues, but I run WebEx meetings. So we could just try setting up a meeting at mutual convenience and just see whether it's something with on the audio end or it's something related to the to the meeting processing. So, but it's really quite unusual. It really is. I mean, so
when we figure it out, make note because it could be fun to do intentionally.
Exactly. I like it. I like your attitude, Alan.
Hey Bob, I'm curious. You mentioned you don't use Zoom because of security, and you use WebEx. The reason I wanted to just bring that up, if you don't mind, is for work, obviously, because I haven't been able to travel, I've been using all these different platforms, ranging from Teams to Zoom to WebEx to BlueJeans to a couple of others, and the company wants to basically say what they paid to WebEx for our WebEx contract is much higher than everybody else. They want to get rid of WebEx, and my concern is that since I'm customer facing, I've got to use whatever my customers can use. And they're asking, well, can they use Zoom or one of these others? Like with some customers, I can use Teams. With some I can't use Teams, and I've used WebEx. But I'm concerned that if I use WebEx, there may be organizations that don't allow anything but WebEx. And since you mentioned security concerns, it sounds like you might work at a place where that's an issue.
Well, I don't work there anymore. I spent 45 years at GE Global Research, and I'll be very brief because I'm not sure everybody else, but we can talk about it offline if you'd like, Alan. Before I left and retired in 2014, I was responsible for delivering this type of service to the General Electric company. And I went through, I don't know how many months, 6 months of trial and vetting and so forth. And we chose WebEx before it became it was bought out by Cisco.
Okay.
And it's the interesting thing is it's a 25-year company. And you probably already know the history, but Zoom was created by a former engineer and subsequently vice president at WebEx Cisco, and he went off and created Zoom.
Okay.
The security concerns probably for another conversation. Again, I'd be happy to share that with you. I can put my email address in the chat window for you, and I'll do that before we disconnect. There are known Zoom problems. Some of them are social engineering problems, and some of them are legitimate security problems. And as you, I'm sure, have read, everybody is scrambling to plug the gap. The market share 15 years ago was probably 80%. Zoom, by the way, is about 10 years old.
Okay.
So about 10 years ago, WebEx had 95% of the market share, and now Zoom, I think, has got 2/3 of it. And it's arguably easier to use with a user interface that people like. It's not dramatically different. And they offer features that a lot of people say, why don't they offer them in WebEx? And the interesting thing is that in many cases, WebEx has thought about this and they don't offer the feature because of security. So an example is that, as you know, you can go in and rename that little label at the bottom of your window at risk, or at your desire.
Yeah.
But WebEx says that is a huge risk because it means that anybody can label themselves to anybody that they want to be.
Right.
You can argue that, I guess. I don't have any conclusions about it. It's convenient that I can add my call letters for this meeting, but if I go to a meeting that I go to tomorrow night on magic and illusion, I can call myself something else or whatever.
It would be easy to impersonate. Bob, this is Mark. Also, you know, over at RPI, we use WebEx. Not that we have this level of security thing, it's just the contract we bought. So therefore I use it. But but you could, on a conference where you're not sharing video, it'd be quite easy to impersonate anybody else by just typing their name.
Right. And then you've got this concept, the social engineering is, have you ever heard of or seen Zoom bombing? Okay, so it's not technically misunderstood, but what it is that people are a little bit free with sharing a link to a Zoom meeting.
Right.
And there are people that just spend hours all day long looking in YouTube and looking in Instagram and Twitter for these links, and then they just drop into a meeting.
Drop in, yeah.
And we had a meeting with the president of Union College back in the spring, where he was talking about all the adjustments that Union College was making to this pandemic. And 2 minutes after the president was in there, there were 3 people who jumped in with Zoom, and within 3 minutes, the profanity, both verbally and visually, caused the host to just terminate the meeting. There was no other choice.
Yeah.
And can that be done on WebEx? It can, but it's a little more difficult.
Yeah.
Why didn't the host just boot them out of the room?
Because they couldn't find them.
You can always find the person.
Because they didn't know who these people were to boot them out of the room. And when they were, and in the case where one of them was identified and dismissed from the room, the person came back as another person within 2 minutes.
Yeah, they got the link. They got the link, and they come.
So this is not done by people who are getting their casual kicks. This is well thought out, and it's done for no other reason than I can tell. I don't think I've seen a political motive or an agenda-based bombing activity as much as I've just seen the thrill that these individuals get.
Right. Just being disruptive. Yeah.
Would that in and of itself be a reason not to use Zoom? I don't think so. And I spent, again, a lot of time in computer security. The other thing, Alan, you should be aware of is that I think the business model for Zoom goes for WebEx goes well beyond meeting. They have WebEx Teams, and that's an extremely powerful collaboration environment. And I think businesses that have made those decisions have evaluated a wide range. And in addition, Cisco WebEx, being a networking hardware company, also offers their own brand of WebEx meeting and WebEx Teams video and audio equipment.
Okay. Yeah.
So it's a much bigger portfolio. And
Right.
I don't know how to advise somebody on how to make a decision.
Yeah, I know. I mean, internally within tech, everything's kind of migrated from like Skype for Business to Teams, and we do everything internally on Teams for the most part. But it's since I do a lot, customer facing, I got to use what the customers use, and I've always kind of migrated to WebEx for a number of reasons. It seems to be the one that is most universally accepted, and it also allows me to set up a share on multiple windows.
Yep.
So I can set up the share for if I've got a presentation and an RSA and a signal generator and things like that. I can have all those things shared, so I can just quickly alt tab between those displays and have them come up without having to stop a share, start a share, stop a share, start a share
Right.
type of thing.
And
I
you
don't think,
actually encountered that tonight when you were showing the visual of your nanos.
yeah,
You had to use your video window, where had you had a couple of images of those, you couldn't
Yeah.
just swap back and forth.
right.
So there's where WebEx excels. So
Yeah.
how does Zoom excel? Well, Zoom has a concept called spotlighting. And
Okay.
spotlighting allows the host to say, I would like, Jim Silva is making a comment. And as the host, he can cause Jim Silva to become everybody's active speaker view.
Okay.
And they've expanded it now to have actually two people, so that if Jim engages in a conversation, and let's say for tonight's example, starts talking about his VNA experience, and Stanley says, I have an interesting question, which starts a dialogue, the host can set up Jim as the sort of the speaker of the moment, and Stanley as the person with the dialogue, and he's controlling what everybody sees.
Okay.
Where on WebEx, you as the viewer have got to go between gallery view, speaker view, or
Okay.
open-ended view.
Yeah, okay. I think I had seen that being done during the GQRP convention, because that was all done over Zoom, and they had like 300 people on that, and the hosts and moderators were able to kind of set up and control some of that. Even though I was just a presenter, they were able to kind of do some of what you said with the spotlighting. I didn't know that's what that was
Right.
called. So
And I have probably a dozen improvement requests into Cisco, and that is one of them, and that's the one that they claim that they're the farthest along with.
Okay.
So it's this sort of classic thing. You've got the old guard who's done things well, they're stable, they're secure, but they got lulled into the business world, which was everything they were doing was satisfactory to the business world. The world changes this winter, spring, and Zoom explodes on the scene because they had all these more modern features. And so do you want the feature-rich, less stable, less secure environment, or do you want, and maybe some would argue more intuitive, or do you want the other? And and maybe at some point they will start to collapse into a closer trade-off. But there are times when, as a WebEx host, I'm frustrated that I don't have the features that I talked about. But I did a survey, for instance. I have a group of 325 people all over the world, and it's a group that we just recently renamed ourselves. We're called the International Conference on Cryptologic History. And so we deal with cryptology devices, but this is people all over the world, and they're very oriented towards security. And I did a survey, and there is a handful of people who are major contributors who just won't use WebEx, or I'm sorry, won't use Zoom. So.
Okay, well, it's good. Appreciate the information. Like I said, I've been pushing back, to at least our IT folks, saying that we need to keep access to it, even if it's just amongst, the Salesforce and the FAEs, like myself. So, because like I said, for me, it's either Teams, Zoom, or WebEx, and then if it's Zoom, it's usually I ask if that's what the customer wants, I say use your account, because I don't have one for Zoom, but we do have one that I use for WebEx, and I've used that most successfully for everything. Because even going back, a couple of years ago, when I had some of my instruments here to put up on Zoom or on WebEx, I would actually have them log in as a participant so I could pass the ball to them, until I got to the point where I could actually just mirror their displays, like with a like a VNC program to my laptop here. So anyway, we're probably boring everybody else with this there, Bob, but
How do I sound anyway?
hey, there you go. Now
There
we
you
gotcha.
go.
All right. I I had to reboot. That's all I had to do. I knew this worked before on Zoom meetings, so
Yeah.
it wasn't an idea. I just grabbed it and plugged the mic and camera combination in. It's a Logitech,
Okay.
and
What model Logitech is it, Stan? It's really very nice.
I think it's 300 or something like that. I can't remember off the top of my head.
Okay, no big deal. But anyway, Alan, my email's there in the chat window.
Okay, perfect. Thank you.
Oh, that's weird. I'm not getting notifications of the chat.
I know, because I sent you notifications at the beginning of the thing to mute people who were not muting themselves because they kept distracting from
You're
Alan's
like me.
presentation. No, what wasn't you? There were two people, and I even sent chats to them asking if they would mute themselves, but they didn't. So
yeah,
C29, yeah, C290. That's it looks like K2SAV has left, but anyway.
Yeah.
All right, it's the C310 that I'm using.
Okay. Okay.
So yeah,
I've been trying to get one of those models. I have like 4 or 5 cameras, but they're all low res. And I've been trying to get one of those cameras for years, or not years, for months, and you just can't get them.
Oh, they're sold.
Oh, I got it way before that.
Yeah, they're all sold out because of COVID. I wound up buying the one I'm using here is by a company called Amcrest.
It's excellent too, Alan. Extremely.
Yeah, the only one I could find, but I'm very happy with the quality of it. So
right. I don't know what the lighting is, but it's got a great dynamic range in the sense that it doesn't tend to blind. Yeah. That's too much for you on the right side of your face.
Yeah.
But much of the background of the room that you are in is in focus and looks very, very well. But I have to say, it must be a combination of everything, Stan. But I can see all the test equipment in the background. That's actually behind you and not a background.
That's
image?
actually behind me. It's my
your shack.
Yeah.
There's a couple of icons on the bottom shelf, and
they're all essentially all icons. I was going to say I recapped the bottom row there.
Okay. Okay. It looks like maybe an SW200 or SW2000 Kenwood meter on the middle shelf there.
Yep, it is.
Yep. Okay.
Well, very interesting. Well, again, Alan, thank you for your time on behalf of the whole group, and JR,
yes, thank you for
president,
that.
is still here.
There's
still a learning curve for folks.
And Alan, I can also send you the. Well, I don't want to send you the file because I'm sure that would be huge.
Hey, JR, I'll help you get the video to Alan if you want.
Or host it somewhere and just send me the link. That's fine too. So.
Yeah, I'll send you a link to a Google Drive account.
That'd be great.
Okay.
Okay. Bye, guys.
All right,
because at Google, I can send huge files to.
Okay, then you just do that.
But I don't know if you want like a 10 gig file or whatever.
No, yeah, I'd rather have a link to a 10 gig file than a 10 gig file.
No, this has been going on for 2.5 hours, so it'll be in the 400 megabyte range. So.
No, it's larger than that.
I don't know what Zoom is doing, but there's no need for.
Well, you got to figure video.
No, the video is just low res. I mean, there's no
video is very high.
Well, okay, whatever. When I run WebEx meetings, I run them for 3.5, 4 hours, and they're very rarely over 500 megabytes. So
this is going to be huge. I can. Zooms are huge files.
Okay.
Very good. Okay,
all right, guys.
Take care.
Take care. 7-3.
Bye.
Ellen has left. Bob, are you still here? Who's left?
Just me. You can terminate it.
No, it's all right. Let me stop recording. JR